Hey guys, welcome back to another live video session, and in today's video we're gonna start off by building a lot of 5010 actuators like this for our humanoid robot. This humanoid robot that you're seeing over here, it has a lot of actuators and most of them can be divided in like two actuator types. This one is 5010 and the second one is 6C12. We're gonna be moving to 6C12 later on in the video, but for now we're assembling a lot of 5010 actuators. So we have assembled two already. We have materials prepared for a lot of the rest of the actuators. We have all the bearings that we're gonna need for this in here. There are hundreds of bearings in total in this robot.
Many more here as well,
Yeah. So this robot is like full of bearings. So we're gonna be needing all of these bearings as we go along. So we have everything prepared over here. We have already installed the brass inserts inside these plastic parts, as you can see over here. These are M3 brass inserts, and we also need M2 for some of the parts. If you can see over here, M2 inserts in there. So we have that prepared already, and now we're just going to be putting these parts together to make all of these actuators. So once we finish these actuators, we're going to be moving on to wiring in today's session as well. And regarding wiring, I have prepared, if you can see over here, all of these encoders in yesterday's live stream session. So all of these encoders have voltage pins, ground pins attached, and then they have these signal cables coming out of them. Now these are not the correct standard, that's why the soldering is so messed up. You need 24 gauge wire for this, but we were kind of in a hurry. We set the deadline to be in less than a week to make this whole thing, so that's why I ended up using this 20 gauge wire which was lying around in my lab. So we're gonna make use of these wires for now. So once we're done with making all of these actuators, we're gonna attach these encoders with these actuators, and then we're gonna be attaching them to the motor controllers which we have over here. So we have all the materials ready. So in this live stream we're gonna be putting everything together, and then we're gonna be able to put together the upper body of the robot. So let's start with first putting together all of the 5010 actuators for the robot. Now one thing we need to be really careful about is these actuators, all of them require an encoder like I showed you. All of those encoders, they come with a magnet. So if I point right here in this actuator, there's a magnet over here. It's reacting to the magnetic field from this L key, and we need to be really careful not to lose this magnet, otherwise the encoder is not gonna work, or we're gonna have to order more encoders. These magnets that come with these encoders, they are magnetized in a particular direction, and we don't want to be losing these magnets. And off the shelf magnets from the markets, they don't work with these encoders. So yeah, we're gonna attach this magnet with the motor using hot glue gun later on, but first we're gonna assemble all of these actuators. I'm gonna go grab some coffee, and then I will join here with my partner in building all these actuators. We're trying to do a sprint today, and we need to assemble as many as possible. So yeah, let's start the process.
Bring one cold for me as well. Coffee.
Alright everyone, welcome back. Yesterday we had a great day. We had, on our very first time on our live stream, 50 plus views. Today we're trying something cool and interesting with this small little character. You'll be able to see that's moving below the at the bottom part of the live stream. I'm not sure if there's any viewers who have joined us if their character appears as well. So like that's at least that's what we were trying to do over here. Now because we're gonna be sprinting, we have a lot of actuators to make today. I'll get right to the work. Yesterday's live stream, in terms of technically advancing in the project, was mess. It was a mess. I was not able to build the actuator. So the MC612 actuator, it turned out a mess. I still haven't assembled it, but I woke up early today and quickly picked up the 5010 actuator and assembled it. This turned out fine. So currently I'm sprinting on the remaining 5010 actuators. If you can see over here, I'm going to be rotating the motor and it's working perfectly fine. And we have 2 of these right now. In total we need 8 right now, and we would really want to finish these 8 actuators in tonight's sprint. So let's get started with this one. We have inserted the brass inserts, we have added the bearings and the spacers, and next step we're going to be adding bearings in this one. Very simple. I'm gonna keep it a bit fast because we're trying to sprint here. Even beyond creating these actuators, there's a lot of work to do. So like we have all of the parts for the arms and the legs 3D printed, just laying here in our lab. We need to assemble them along with the aluminum profile to create the body of the humanoid. So this is the second one. I'm gonna make sure this is aligned perfectly well inside of here. Alright, both of these are finished. Next up, we're gonna attach it with the next part. Here it is. It's like this is the part on which we're gonna be mounting both of these. I'll just grab this one right now and make sure it snaps inside. There we go. And quickly this one, I'm gonna snap it in here. Alright, came out pretty clean. Now we are going to align this here and insert it inside this one and make sure it snap fits. Okay, there we go. Next up, this part right here, we'll pick it, we'll align this, and M3X25 we're gonna insert them. Grab a few of these. So because I have already assembled 2 of the actuators, this time I think I'm moving pretty fast, and at this pace I think I should be able to assemble all 8 actuators within just 1 or 1.5 hours, which will be a huge progress, because later on we also have to assemble the M6C12 actuator and then also assemble the arms along with the aluminum profile. So I'm really hoping we can finish hopefully all of this by tonight. We're not sure. Let's see how the progress goes. in 1.5 hours. This one. So today, after assembling just these two actuators, we had a small cleaning session of our lab. This table had become such a mess, it was unrecognizable. Like you wouldn't be able to identify anything out of the mess that this table was. So we had a small cleaning session after these actuators, and now we are just printing on the rest of the actuators. So I have inserted these. Just gonna quickly tighten the screws. This one done. This one. I think if we have any viewers, they are supposed to show up at the bottom part of the screen, just like there's one character right now. So if there's multiple people watching the stream at the same time, they should appear on the bottom, but for some reason I think this specific plugin is not working as it's supposed to be. I'm gonna have to take a look into that as well later on. So currently we do have viewers, but they're not showing up at the bottom of the screen for some reason. Alright, 3 screws tightened up. For some reason this one is not going in. I'm just gonna have a look quickly. Try to apply some force on this one, because we really want this part to be compact and together, so that way these rings do not slip out of place. They really have to be snapped in tight. So this part right here, one of the most defining things about the actuators is their size. They have to be as compact as they possibly. There's different sort of mechanisms for driving the actuators, but this is a pretty compact size for an actuator, especially with the amount of torque it can produce. It's pretty neat. I can really feel the difference. So the speed at which I am rotating the motor, it really builds up the torque by the time it reaches over here. So this one is moving really slow, and it's pretty compact as well. So that's why we need to have these parts as compact and tight, so that way the rings do not slip out of place and the torque or the force is transmitted perfectly. So just gonna close this one. Alright, we have this one pretty compact, and now we in the next step we want to grab this part. We need to add 2 bearings inside of here. So the bearings I have over here, I hope they're the right size, because we have different sizes for M6 C12 actuators and the 5010 actuators. Just gonna grab a scissor, open this up. So guys, tomorrow there's a UFC event as well. Any UFC fans here who are waiting for this pay-per-view? I think tomorrow is gonna be a pretty good one. Not even the main card, but even the fights before that. So like, I'm pretty excited for them. this one, I'm just gonna compare the sizes of both bearings. As you can see, they're different. So this one is for the bigger actuator, M6C12, and this one is the one that we need right now for 5010 actuator. And you can see there's slight amount of oil on my fingers as well because of the lubrication on these. So they're already pretty lubricated while they were inside of the pack. We want to pick up one of this, insert it over here, make sure there's a snap fit, as you can hear. There we go. And on the other side, we want to pick this part and insert it just like that. And once again, we want to make sure it fits with a snap. And I'll just push it. There we go. It fits in really neatly. We want to grab one more bearing and we want to place it over here. Snap fit it once again, like there we go. Came together pretty nicely. And now we need to insert these parts, so like this one and this one. We have these two. I just quickly want to make sure there are no messy supports over here. I want to make sure that this part is really clean before I insert it on top of this actuator, because we're just making the assembly once. We're gonna make sure it's done perfectly right. So this one seems pretty clean. I'll first of all insert this one on one side. So put it on top of here like this. Make sure the holes are aligned. Align the holes and just push it on top of it. Alright, that came together pretty nicely. Next up is this one. I'll just quickly make sure that it does not have any supports that will cause a problem later on. For that, I have this handy little part over here. It's a bit of a mechanical struggle, but you have to make sure that there is no part over here that would hamper the assembly of the actuator. So there are small parts coming off. Alright, good from this side as well. Now this one. Alright, seems to me this is pretty good now. I think it should be able to fit in relatively good. This is one of the parts in assembly which I almost always have slight trouble with, because I want to make sure it snugs in pretty tight and okay on this bearing. But usually it always does not. Usually it always does not. So let's try over here. We're gonna make sure that the holes are aligned perfectly well over here. And I'm just gonna push this. I need some slight adjustments on this part. So enter this one here, make sure it snap fits. Just got the coffee from the local combini.
Yep, ensures the nitro goes with the really with the momentum. By the way, the speed with this one is pretty fast as compared to the last one because we've already made two before. So this one is it's being assembled really fast. I think within an hour and a half we should have all of the 5
Yeah, then
detected.
after that we're gonna attach all the magnets with the hot glue
Yep.
gun, and we're gonna put the encoders on there.
Yeah, encoders and wiring. In parallel, I think we should start the process of the arms on with the aluminum profile in parallel with the wiring.
We had 3 concurrent viewers.
Yep.
Damn, that's crazy. Like, did they show up over here? Like in
None of them. So they're not showing up.
I
don't
think
know.
it happens when someone is in the chat. I think
Ah.
probably, but yeah, we just added this today.
Is that the only option? The chat one?
Yeah, I think so. That's the only option.
Is
If-
it like I heard there was an option for everyone?
No,
that
no,
not the
the
case?
the option was for everyone who's in the chat, who's active in the
Ah,
chat.
okay.
The other options are if subscribers are in the chat or
Makes sense. That makes
by
sense.
using custom commands. But we're still learning the bells and whistles of this. Next ones are gonna be like next couple of streams. It's gonna improve.
Yep, definitely. There is still so much to add. There's music to add. Still a lot of things to do. Why is this one slightly inside of the bearing, but these ones are outside? Like it's not snugging in tightly for some reason.
I think when you have you added these parts in there yet? I think when you
I
attach
understand. So like I should not have put this. I'll try pushing it to its maximum right now, like this. Okay, the bearing is there. Ah, this time it went in well. Okay.
I'm gonna start working on the other one in parallel.
Mhm.
So, let me move on to that side. So I have access to the soldering station and everything.
Okay.
So I was talking earlier about the UFC event tomorrow, and I think this one is gonna be a pretty good one. Yeah. I think the Chimaev versus DDP was the best one for the year. Hype wise, what generally was expected from the card, even though the fight was, I found it really exciting, the overall fight, and just how much dominating the Chimaev was, and how he just neutralized the entire game of DDP. But Yeah, this Pereira one is gonna be an exciting one as well. Like it's one of those cards during the year that you really look forward to.
Yeah, for this one, I'm not just excited for the main card, but also the other fights as well. In general, most UFC events are a blast. They're always good, but this
Ye-
one is especially really good.
Yeah, Proton is making a lot of excuses this time around, which I'm not a big fan of. But imagine if he actually was unwell during the last fight. If he wins this one, it's gonna be really crazy. Like he's already, even after losing, he's already one of the biggest superstars UFC has right now. So if he wins, it's gonna be like a huge win for UFC as a whole, for their company.
Both are extremely good fighters. So like the fight is gonna be pretty interesting.
So let's try and join them in parallel. So I'm gonna move all the parts for this one over here. L key, this did I think is this the part for
Yeah.
okay, and for
Just pick one.
yeah, this one.
Yeah.
I'm gonna move forward with this one. Let's try to like do it in parallel and
Do you have a straw?
sprint
with
through
this?
them. Yeah, so I think this part is for this.
With this one, do you have a straw?
I think I forgot to bring this.
I'll just grab one from kitchen then.
Yeah, so we have yet to add 4 M2 inserts in one of these, but we'll simply deal with that when it comes to that. For now, we're gonna finish assembling the ones we already have. Yeah, it's this one. You know what? Actually, I'm gonna like take. I'm gonna heat up this solder and I'm gonna insert those brass nuts. So when we move back, everything is streamlined. There is one issue we're facing while building this, is that the hex stands we ordered the right size hex stands, but the external diameter of that hex stand it's not right for this 3D print assembly. So if you can see over here, these hex stands they're loose and they rotate in there, so they're not solidly attached in there. So what we're doing to move around this problem is we're using hot glue gun to put it in its place in there. That's what we're doing right now, and I hope it works because it's like a really messy hack. Ideally, depending upon where you live or what manufacturer you're ordering this from, the external diameter for these hex stands it's gonna be different, because while selling these they only mention their internal diameter and the length of these stands. So the external diameter is gonna be different for all of these, and I just hope the fix we are doing for this, the hot glue gun fix, it ends up working for this. I'm a big fan of coffee with chocolate, and people have told me their really extreme opinions regarding this issue in the past. It's cafe mocha, and it's available at pretty much all the franchise cafes, all the standard cafes, but for some reason people really hate it, those that do not drink this, and they say it's basically like a smoothie at this point if you add chocolate to your coffee.
Alright, so I'll just disassemble this. because I want to make sure it goes in perfectly well. This is the bearing, and this is the part we need to insert here. Okay, it seems like it snugs in pretty good.
The Sora 2 model was just released by OpenAI, and it is so dystopian to see it.
Is it good?
Yeah, it's good, but CoffeeZilla made a really good video on it where he was saying that basically, like, took all the copyrighted material and people are making their own really accurate looking episodes of Rick and Morty, Pokemon,
Interesting.
SpongeBob, and the voice acting, the animation, everything is absolutely spot on. So it's really sad to see how these AI companies are just ripping off all the IP stuff, and they're using that to train their models, and how people in the future, all the IP stuff will become meaningless when everybody in the world will have access to this kind of technology, and they'll be making like their own episodes or whatnot from using that AI model.
So this is a pretty interesting case because it seems like I have clearly done something wrong over here. You can see that this does not fit in. There's clearly something wrong over here, which was exactly the case with the M6012 actuator. So I want to find out where exactly did I go wrong in this one. The part so far seems okay.
I'm just gonna place a lot of bearings here.
It rotates almost perfectly well.
You might have to disassemble the whole thing step by step.
Yeah, I might need to do that.
Yeah, I think this part looks pretty much accurate at this point.
How close are both of these? So they're pretty close.
Yep, there's only the gap from the spacers at this point. I think we can tighten these a bit more if there is still room to do so.
Yeah, to tighten them as much as possible.
Yeah, but we don't have to go overboard, otherwise the 3D printed parts, they can break really easily. Also, the issue with brass inserts is if you apply too much force, they start to make their way around the 3D printed part that they're sitting in, just like the way screw.
By the way, the entire screen looks so awesome and so robotic. If this was this live stream is only missing music and a couple of chatters at the bottom.
Like
it's almost perfect.
Yeah, a lot of chatters and also the speech bubbles that come up when someone is chatting in the.
Yeah, they're pretty amazing as well.
Yeah. So far, we have not gotten any comment in any of our live streams, but this is the third live stream, so we're hoping to get a comment sometime soon in the future.
Yeah. So, adding this part.
So for these supports, it's a good idea to print a lot of these. I think you're able to see these. These are the supports we need to add in between the bearings.
These are spacers, yeah. We need to add.
Yeah, spacers. Or 3D printed washers, you can call them. We need to add a lot of these in between the bearings. Building robots is like such a fun job if you enjoy building stuff, or if you're like an artist, if you enjoy creative stuff, because a lot of this I have found to be really creative, especially the design part. And when you build robots or small robotic cars or toys, or even a humanoid robot, what you're doing is not like exactly electrical engineering or embedded or any single thing. It's, the field is called mechatronics, and it's more of a generalized field across the board. So you get to learn a lot of 3D CADing, hardware design, then you get to learn electrical circuits, electrical connections, then you get to learn a lot of hardware side, for example soldering, wiring, electrical connections. So it's a really vast field in terms of skill sets, and you don't have to be an expert in any one of them.
Yes, expertise comes with time. As you keep working on the project, it all compounds, and over time, looking back, it's really easy for you to learn everything.
Yeah, and
You
you
know,
you don't even have to work on really crazy amazing projects. You can simply work on things that you really enjoy doing. For example, you can make anime action figures even. So this is a project we built a while ago. It's entirely 3D printed. There's some dust on it. It's just sitting in our lab collecting dust at this point, but this project has a lot of electronics stuff in there. So this display, it can fetch anything online from the internet, and this display can show that information. Then it has this knob, a potentiometer, with which you can control the rotation of this whole table. So this action figure, as you can see, it sits on top of this table, and you can have it sitting in the background anywhere, while making a YouTube video or whatnot. Maybe you can have it on a shelf, and when you rotate this knob and you power it on, it rotates in clockwise direction, and you can control the speed of that rotation. There is so much more cool stuff that you can add to projects like this. And if you know how to build something like this, if you're having fun while building something like this, you're basically doing robotics at that point, because what we're doing right now, it's not that far different from these action figures. The robotics field for a really long time was not open source or not easily accessible because of the manufacturing. Now, manufacturing costs during the industrial age, they were really high, especially if you want to get a custom design made for injection molding or something like that. It takes hundreds of thousands of dollars to make a single design for injection molding. It's really expensive, but with the advent of 3D printing, all of this stuff has become like viable option for everyone. So you can have a 3D printer in your lab or in your garage, and I'm here back in my garage like Ty Lopez. You can build pretty much anything that you can design on the computer.
what I'll do is I'll just keep this one in the side over here, and in parallel I will start working on one more. And while assembling that, something might come to mind. Yeah, something might click as to why those parts are not just fitting in perfectly well. So let's just start with this one. Once again,
The beadings for these parts are these ones?
the black ones. No, the black ones.
Oh,
Yeah.
okay, gotcha.
Those big ones are for the M6 C12 actuator.
Well, once again we have 3 concurrent viewers in the chat. I mean, it's so awesome to see. Like, thank you guys for tuning in. If you guys have any suggestions for the live streams, or if there are any specific videos you want us to make,
let us know in the comment section or in the chat box. Yeah. But yeah, the deadline we have set for building this robot, it's less than a week, and in less than a week we will have this robot ready. And once we build this robot, we're gonna make a summarized video on our channel, and I'm also gonna have a playlist, a separate playlist only for building this robot. So if anyone is interested, I'm gonna be showing in that playlist. They're really brief videos, but I'm gonna explain how you can solder all the encoders for the robot. So we did this soldering in a separate live stream, and I'm gonna explain how to do that in a really short video, and then we're gonna explain in that video how to make the 5010 actuator and the other 6E12 actuator, and the general assembly for the rest of the robot. Yep, so at this point we have already made these two actuators, so this part is just repetitive, and so we're just doing it really quickly, just sprinting through all of the actuators. I think all of the actuators should be ready at an optimistic timeline of 1 to 1.5 hours. Yeah, I think all of the actuators, 5010 actuators, will be ready in this time. Yeah, and right after that we're gonna move on to soldering the encoders with the motor drivers, and actually before that we're gonna place all the magnets we got with the encoders on these actuators
and the motors. Yeah.
Okay. By the way, these bearings do. These bearings are delivered already lubricated. Yeah, most bearings are, like pretty much anywhere in the world. If you order bearings, you get them in really nice condition.
Yeah, they're pretty slippery and pretty smooth.
Yeah, but the bearings here in Japan, they have a totally different feel. Most of the hardware components that are manufactured here, they are really high quality. Before this, a lot of hardware components we were ordering were from like third world countries or China. But when we got our hands on hardware components from Japan, they were a lot more expensive, obviously, but the quality was like totally different. Okay, now I think we are gonna, I have to place this in there like so, and I'm out there. Yeah, I think we needed to align. I just dropped a bearing from somewhere. Yeah, it dropped from here. Why did it fall off though?
Because they're not stuck in tightly. If you just turn this one, they'll come off.
Gotcha. So I am gonna.
Yeah, they already have the lubricant on, so they're pretty slippery.
And let's put this in there. I think that's the way. Yeah, and. I'm not sure what's the like. Do we place it over here like this? Oh, upside down.
Yep, and these will be inserted in here.
So okay. So it's gonna be like a satisfying click sound, snap fit sort of thing.
Yeah. So now you can screw them from the other side.
Yeah, snap fit in 3D printed parts. It's a really nice feeling. If you've never, you need to feel them to know how satisfying they are. What's the size of screws we need to insert over here? What's the like?
So I'm 3x25. I have them over here. Yeah, these ones.
These ones. Okay. I need to. Let's place a bunch of them here.
This one snaps inside of here. the design is really well made. Like if you play around with this, you realize really fast how efficient and how clean the design is. If you know, when you're building a robot or something like that, there are so many options for 3D CADing softwares or design softwares, but in terms of pure robotics or industrial design, I would recommend Fusion or Autodesk Inventor. Those are the ones I have used. Right now I use Fusion. There's a free version of that. You don't have to pay anything if you're like a student, or if you're just starting out, you don't have a company or a corporation.
SolidWorks is also pretty famous throughout the industry. Back when I was in university, I used to hear that all the time, that SolidWorks is the industry standard. But they say the same thing pretty much about any software, anything that's even a little bit trending. But SolidWorks is also pretty famous, and a lot of files on GrabCAD and on these online platforms, they do have SolidWorks parts on them.
Yeah, so you can even modify this open source design if you know a little bit about Fusion or other softwares. You can even design these parts on Blender if you're into it, but that leans a lot more in the creative direction. I really love Blender. It's one software that I don't fully know how to use. I only know a little bit of sculpting and really basic shape modeling in Blender. But if you know what you're doing in Blender, you can also make these components in there. But if you're willing to modify this robot or this design, you can do that really easily in Fusion, especially with the parts that are not available in your locality or where you're living. For example, the example I showed you, this hex nut that's in the design, we were not able to find the correct size hex nut anywhere from Japan. And right now, if we open up Fusion, we can fix this design so that it snugs in really nicely with this hex insert. So you can modify these designs depending upon where you're living in the world, what materials you have access to. We're trying to sprint through this thing, so we're not going to be modifying this design right now. That's why we have our handy glue gun with us to fix these issues for us.
If there was no UFC event tomorrow, we could have just kept going for 8 hours straight tonight for the live stream. A really long sprint. But the event is pretty cool.
Yeah, these events in like Western countries, they're like they're a big hassle for Asians time wise. They're always at the like a really wrong time. Yeah, so some of the supports are causing issue. You really have to get in there and press it really hard so it makes its way through the 3D print part.
Yeah, I'm waiting to see how this one turns out. If there's gap like this part, or it fits perfectly.
Yeah, I think it's gonna this part so far it's like perfect. Even the one you made,
yeah, it's perfect. But
it's really
I don't understand where the gap comes from. It won't be that big of an issue because we do have M3X60 screws.
Yeah.
So it can pick up the hex inserts from the other side. There's just gonna be a little bit of a gap that looks maybe just a bit bad.
Yeah. So one other important thing that we have realized when working on this robot is the M3X55 screws that are needed for this design, they're ended up not fitting in the design. So we are using M3X60 screws for this 5010 actuators. I'm gonna show that part in a bit when I am done assembling this, but the 55 size with M3 screws, it's really small, and it does not make its way to the brass inserts on the other side. So that's something you're gonna have to deal with if you're working on this robot. But overall, the entire design is really smart, it's really well made, and it's really easy to understand. Once again, if you want to build this robot anytime, I will have a playlist on my channel which will go straight to the point on how to assemble every single part. So yeah, this is a really tightly snugged part, and as you can see, all the screws over here have made their way to the brass inserts on the other side. So these brass inserts are gonna hold on to those screws, and it's like tightly snugged together. Yeah, most parts which are mentioned on the bill of materials on the UC Berkeley website, there most of the parts are fit perfectly nice, perfectly together. But there is issue with some parts. Some parts are not mentioned. Some of them just do not fit. These we need these bearings. Yep. These so ones. It's like a level fit or not? It should snap in perfectly well. All the way to the inside? No, not okay. All the way, just this much. No, you don't have to add the other one right now. Opposite. Okay, this like way around. Yeah. And we also needed to keep it at a 180 degree offset, right? Not sure about. Yeah, that's something we need to take care of. Did they mention in the video? Yep. I didn't pay attention. Not in the video, I think. Is it this way? No, opposite. Opposite yep. Way. Okay, like this. Yeah, I think they mentioned it in the video, or they. Okay. Now yours is. I think yours fit just perfectly well. Yeah. So maybe it's the one. You can see that it's outside of here. Yeah. So I think the issue is the 180 degree. Try on this one then. Offset. Yeah, just let me give it to me. So this is the bearing. Where did this fall from? Okay, we're gonna have to deal with that later. Yeah, just take off this bearing for now, and just insert this inside of there. Let me add the offset over here because it's really important. So the views went from 9 to 8. There was probably some repeat view. Probably. Yeah, so I wonder what he came back to see. Let us know in the chat what you're like most excited about in this project, what you're looking forward to. If this fits in, then it's a good news because it means that M6 C12 actuator is also perfectly right. Yeah, it's like you need so many rotations to make it offset by 180 degrees. So you know both the phase between both of these gears is changing constantly when you're rotating them. It's like such a cool and genius assembly mechanism. Yeah. I think we're gonna have to rotate it a lot more. I don't think that much rotation is required. Yeah, but it's like staying. It's pretty much okay. Just a little bit more over here on this side. So the phase offset is pretty apparent. I'm gonna show in a bit what I mean by phase offset. Okay, yeah. So if you can see over here, these the two teeth are not perfectly aligned. If you're able to see it clearly, it's not like visible in the chat, but if they were aligned, would have been really difficult to put it in there. I think we can even open up this design and put it at offset and then put everything together. I think that the assembly itself is wrong. Let me try to put it in there.
We might need to open this up.
Yep, it's not even going in there.
No, you have to put it like this. Okay. That is exactly the problem. Both of them do not go in perfectly.
Yeah,
well.
yeah.
So you have
So
to
they
open it
they
up.
need to be at an offset of 180 degrees.
Okay, that's interesting. Where exactly did this issue arise?
Yeah, the video we're gonna be uploading on the 5010. We will. Did you mention that?
Okay.
We're gonna have to edit that in using text, or maybe we
Yeah.
can record an audio and we can
Yeah,
mention it.
that would be useful.
Yep.
That video is pretty good because there's not a lot of mention of this actuator on the internet.
Yeah, so instead of using this hardware L key, what I recommend you to have is, if you have access to a automatic machine like this, it saves a lot of time during the assembly or disassembly of these components. So if you have access to this in your lab, it's gonna save a lot of your time. Let's pull everything apart carefully, and now we're gonna put them at an offset of 180 degrees, exactly like this. Yep, it's now at an offset of 180 degrees.
Okay. And now?
And then we're gonna try to push it in. So you have to wiggle around slightly.
And snap in, tuck.
Yep, I think it should be able to go. Yeah, this is the max we can push it to, as you can see, like on either side. Or is it the let me double check one more thing. We need a black bearing to put on here. Let's yeah, it's here. So what's the correct orientation to put this in? Like, does it go like this?
Like this, like this.
Like this, okay. I think it should go in
Correct?
yeah,
This time
correct,
around,
correct
okay.
this time around. Let's try and put this. It's a bit difficult to put everything together now that we have these screws. Let's try and put it in there first before okay, let's tighten these a bit.
Yeah, just a little bit.
So when fastening these components, it's a really good idea to move in diagonal directions so that everything is nice and even.
Where are the bearings?
The here.
No, these ones. These ones.
Yeah, here.
Oh, yeah.
Okay, and where's the part you
Okay,
is
you can use
is it here? Let's try. Yep, it's going in perfectly this time around.
Wait. first step. We'll just snap this in. Look for this satisfying sound. That was a little too low, but then it needs to. No, no, which was the part? I think this one. It's supposed to go in like this. Yep. Surprisingly, this one came out perfectly well.
Yeah.
Oh,
I put it upside down.
Yeah.
This way around, and it's also gonna go in there nicely.
Ah, great. Oh, that's a huge relief. It means that our MC612 actuator is also correct.
Awesome. Yeah.
Yeah, we just need to open it up and tighten it once again.
Yeah. Okay. So now
That's a huge relief.
I'm at a bit of loss at the next step. What are we
Oh, so for the next step, okay, so like here we have the bearing. We have pushed this as much we can inside. We need to grab one bearing and put it over here. Like,
okay. That was a really satisfying sound.
Yeah.
Let's see if we can replicate on this one as well. No, it just like it slipped in. It didn't give us that
Okay.
satisfaction once again.
And then with the help of an L key, we're gonna make sure we have the parts aligned.
Like
Just
any random
Yeah.
direction.
Yep. And I'll just put it in this one, this glue one, so that way I can align on both sides, and then just press this.
We have where's the
Other L keys.
no not the L key, the black 3D.
This one came in so perfectly well. As you can see, there's no gap, there's no play between these two assemblies. Next up, with the same L key, we're gonna push the second part as well. So,
On the other end.
yep,
Okay.
perfect. Yep, this is almost perfect, yeah.
I'm gonna try to align everything on my side as well. Okay, we've got two 5010 actuators going side by side. Both of them seem to be turning out really well up to this point.
Now we have to attach the BLDC motors over here.
Okay.
Can we quickly join this one as well? What is this one lacking? I think we just need to snug this in. Yep.
Yeah.
And
And the upper and down, that part, can you
Yep.
grab that? And I think let's push everything up.
up till this point.
Yeah, up till this point, because we have to use the hot glue gun, and that's
Yeah.
a bit of a rough thing to do. It's a bit of a rough process. The holes are. We're gonna make sure using this L key everything is aligned well. Is this part for? Yeah, it. Yep.
Yep. This is how it goes in.
Just like any random one.
Just push it on. Alright, we'll just paste this one here. Let's grab the next part.
Yeah, how
We
many
have
do we
one,
have?
two,
We have
three,
3 left.
4, 5. Yep, 3 more left.
Okay, let's put it over here and put it over here. They look so cool when they're assembled like this.
Yeah. Really amazing parts. I'd like to have a screenshot of this and put it on the socials. It's pretty good.
let's
Why
drop
does
it.
this part not have any brass inserts?
So we were gonna make a video on that.
Okay.
It was for the recording purpose. Yeah, you can first finish this one up and then we can.
No, you can I think quickly finish those. I'll insert the brass in this one and then assemble quickly.
Yeah, for the YouTube video, we're just gonna grab the process of you applying the brass inserts from here.
Okay, we can do that.
This is the best solder for that purpose. Just place it on that table and use this wire. Let's attach the wire over here. Now it's gonna get really hot in a second, so be careful with that. I'm gonna be assembling this meanwhile. Once you get a hang of it, it's a really quick process to put them together.
Yeah, only the first two actuators really took some time. After that, the other ones are coming together pretty easily. There's some over here.
And we have a lot of soldering to do after this, and we have to attach the encoders on all of these actuators, and after that we can have some hope of putting together the upper body of the robot.
Yep.
Yeah, I think we should be able to move to that stage by the end of today's live stream.
I also think so. We'll have the aluminium profiles and the assembly. If not finished, then at least starting.
Yeah, I don't know what what level of precise soldering is required in the motor controllers. A lot depends on that.
Yep.
We're also gonna have to solder all the CAN bus components in there as well.
Yeah, wiring is gonna be a huge task in its own regard. Yeah. Like all of these need to have their motor drivers and encoders attached with all of these. It's gonna take some time. It's definitely gonna take some time.
Yeah, we are making them, and we're putting all the actuators in this stage over here before moving on to this stage, like putting in the motor, because like we mentioned, these hex stands are not the right size and we have to use some hot glue gun for that stage, and it's a really precise job, so that's why we're not proceeding to that part yet. Once we have all of these ready, we're gonna move to that stage. It's really easy because there are so many 3D printed parts. It's really easy to lose track of what parts are for which unit. Yeah, so yeah, this
Cannot
one
find
is
it.
missing one of the what do you call it, the between the helical gears,
You can use
the
this
offset
one.
joint.
Use this one.
Yeah, so there are so many parts in this assembly. It's really easy to lose them somewhere in your lab. And also, if your lab looks messy, it's gonna be extra difficult to find parts around. So make sure you label parts for all the actuators and you have everything ready before moving on to the assembly part.
I was mentioning to them early on that before starting the live stream, this table was such a mess. You wouldn't be able to find any part. This table was a huge mess. We had to clean it before starting the live stream. And that's pretty common with hardware projects. So like after every one project, you need to clean the lab once, or the mess really builds up. This part.
This unit is at almost a perfect 180-degree offset when we put it together, as you can see over here. So the crest and trough, they are totally at a 180 degree. So this is what it needs to look like when you snug it in with the bearings.
Now this is important for this part to snap fit perfectly in the bearing assembly. It's very important for this part to be at a 180-degree offset.
Yep. Otherwise, it's gonna like ruin the whole assembly. It's gonna not be tightly snugged in, tightly put together, and it might cause some unforeseen issues later when you're testing the robot. Okay, now I'm gonna add these screws. We need these screws, right?
Yep, these one M3X25 screws. Hardware sprints are really good if you have all the parts in your lab. A huge part of a hardware project is just the components that you need for the hardware project. You have to plan and source these components and materials way in advance. That's half of the project.
Yep, and you also face a lot of issues when working on these projects. Like I mentioned, the hex screw was not fitting rightly in place because the bill of material, the hex screw, it mentions you're probably gonna be receiving a different hex screw when you order the exact same thing in your locality. So you need to have enough tools in your lab to wiggle around that problem. I'm moving diagonally once again, tightening these screws, and you have to tighten them all the way, but not too tight. You don't need to. You don't want to like end up breaking 3D printed parts. It's gonna take a long while for them to be 3D printed again if you like end up breaking one. If you can like put it at the center, we need to add this part in the video, like inserting brass inserts.
There's a lot of brass inserts to add in all of the actuators. You really need a lot of these parts. If you're planning to build this robot at any time, try to keep in mind already the bill of materials and ordering it in advance, considering the timeline it will take to deliver these parts to you, and considering that timeline within the scope of the project, because it took us a long while to get all of these parts.
Well, someone left a like on our video. I think it's a guy who watched our video for an entire like 4 minutes or something, which is like really crazy to see.
Yeah.
Shout out to whoever looked at this stuff, this like electronics and geeky stuff for 4 minutes straight.
That's so crazy.
Yeah, we're gonna be doing some anime illustrations and 2D animations live streams too after this. And yeah, we'll see if there are any anime fans in on our channel.
There's gonna be a lot of anime fans. Like almost all of the tech Twitter or tech YouTube, they're all anime fans. Everyone watches some anime and everyone
Yeah.
has some their profile picture of some anime character.
Yeah, it's not weird enough to just be a nerd at these things. You need to be extra weird and watch those cartoons, quote unquote.
Quote unquote cartoons.
Shout out to all the weirdos who watch cartoons.
Okay. By the way, these parts look so cool after building.
Yeah,
Just by design.
like it's such a compact assembly, and these helical gears, they look really cool when put together. I'm gonna there we have the bearings over here. They look like the thug sort of chains you wear on your arms. Let's put it in there nicely. It's like a mirrored component. It's so cool, you can start from either way. Then we're gonna put this in there. Once again I did it the wrong way around. Yeah, it came out
perfectly well. Yeah. I think we'll have the actuators ready pretty soon.
There's that
Within like 1 hour, we will have all of the actuators ready, and we'll be moving on to the aluminium profile part and the wiring part as well. So like the drivers and wiring, that will take a little bit of time for all of the actuators. I think a really ideal milestone for the end of this live stream would be that we have finished soldering.
Yeah, soldering is gonna take a while.
Yeah, that will take some time, definitely. And we have aluminium profile and hands, if not fully attached, then almost sort of ready. The skeleton structure sort of ready. It would be a really ideal milestone for this live stream.
So we have 2 more to go so far. From what, or 3 more to go. I'm not entirely sure, but let's keep on going with this part. I have 1, 2, 3, 4, and 5 of these. I wonder where all the parts for the rest of them are.
Which one? For which
Yeah,
one?
for this, and because
Huh?
we only
1,
have
2, 3, 4, 5, 6. The 7th one I am already building. This is the 7th one.
How many are there for
8 total.
8?
Yeah. So like, why do we need so many of these?
But why are there like so many? Did we print?
Because they belonged here. They,
Okay,
They attached with the
okay,
motor.
okay. Ah, gotcha. So they are like mirrored components, so they look exactly like the ones we already used in there.
Yep. I have printed just 1 or 2 extra of each of the parts. Just like you were missing one, I just grabbed from there, but not more than that. So if there are 8 total actuators, at maximum we would have parts for only 9.
I think we need to keep the colors of the bearings consistent, but they are the exact same size. But just for like aesthetic purposes, we can keep the color coding the same for as long as we can. But it does not matter if you like. If you're the one building the robot, you tend to remember everything about the design. So later on, if you want to open up the design, if you want to make any changes, you know what to do pretty much.
Yep.
I'm gonna grab these two and I'm gonna put these bearings in there like so.
Any viewer who is watching this, are you guys into robotics or software?
Yeah,
Or just
most probably, like if anyone is watching us for more than a couple of seconds, like more than 20-30 seconds, they are probably interested somewhat in the robotics, because
yeah.
otherwise
or
for
in
someone
the
who's
tech space in general, yeah.
yeah, otherwise the whole thing looks really dry. At least the way we've set it up, I would have much preferred there was a camera on us as well, and it was more of a like streamer setup. We will reach there eventually, but for someone who's not interested in robots or tech in general, it's the stream looks pretty dry at the first. The first impression of it is pretty dry.
Yep. Uh, one lo-fi music and perhaps one camera on us. Even without the camera, with the lo-fi music, this is already really amazing.
Yeah,
But if there's a camera on us as well and there's lo-fi music, everything.
yeah.
will be
This is really amazing. It's like it's a subjective opinion though. Yeah.
no. It objectively looks cool. it looks cool, objectively. There's something about these actuators and their shape looks very cool.
Yeah, once you are done putting that, yeah, if you can bring it a bit over here. Once you're done doing this, we can grab a screenshot for this to like post on X
Oh, yeah.
or something. Because all the bearings, especially over here, they look really like they do give a vibe of like there's something getting bearinged over here.
You can take a screenshot right now. Just
Yeah,
take one, yeah.
I mean, I have grease all over my hands from the bearings. If you can grab the screenshot real quick. Is this like a screenshot or the copy one?
The screenshot.
Gotcha. Good then.
Okay, last bit of brass inserts and this part before we start sprinting on assembly of this actuator as well.
Whoa, that was the issue. This screw is a bit too long, so be careful with this, guys. There was one imposter among these ninjas.
One imposter among the screws.
Yeah, so be careful with the. Make sure you have the right size for all the screws.
Screws Among Us. Among Us Screws version.
That's a good brain rot idea for a game.
Yeah, just the screws hanging around.
Yeah.
Trying to find the imposter. There is an imposter among us.
There's a screw among us. Yeah, we also have stainless steel screws with the white coating, but the black ones, they look way more sick on the white 3D printed design. it's already well in there.
This is
Look how the whole thing is going on in the like corner. It looks really weird. You can move it a bit over here, way in the center. Yeah.
here. Okay. Yeah, but we just need it for a very brief part in the video. We can just show up while we're explaining.
Yeah.
First of all, you need to-
Just let me grab this iPhone and record a close-up video as well.
Yeah.
Just a second. Yeah. One more. I have now like fixed the composition, so
Okay.
we also have a lot of actuators in the background. It looks really cool, this composition.
Alright, the brass insert is
Just
melting into the plastic. There we go.
cool. We just need to tighten these screws. Like tighten email.
I'm just removing it from the video to the corner. I
Yep,
think that much
yep,
is enough,
yeah, we have got a
Because-
decent shot.
At this point, we need to sprint a bit more and try to cover as much as we can into tonight. There's a lot of work to do tomorrow as well on the other projects that we have, as well as on basic stuff which we want to get done tomorrow, like adding lo-fi music to it,
Yeah.
making it better. So like we have to do it tomorrow. We should not delay it to later live streams. We're almost working every day on some project or something, and it's cool to just keep live streaming them alongside. And this part,
It's looking good so far, and yeah, let's prepare this thing. So we have 2 bearings left, and 2 is exactly what we need right now. Actually, we need more than 2, but are these gonna fit? Nope. Do we have more of these bearings?
I don't know.
We're gonna have to look for more of these, because these 2 are the last ones from what I can see.
That's gonna be a huge problem if we're
Yeah.
not able to find more of these.
Wow. Once again, such a satisfying sound every time. There we go. Another one done.
On my end, I have inserted all of the hex inserts in this one. And
Yeah,
we
you can start adding the bearings, and I am gonna try to find if we have more of those bearings. I'm not entirely sure if we have them.
If we don't have any more, then basically
Yeah, then it's not a good idea to even proceed with the assembly.
what's inside of this blue color packet?
Which blue?
This blue and white, yeah.
Yeah, this is like the anchor USB hub.
Oh, okay, got it.
It's not the.
Did we really not have the bearings?
Did we order the correct amount? I think
not
we
sure.
will
No,
have to double check that.
We'll have to double check the bill of materials list, because there's no proof we had enough.
Yeah, like it's an
They-
entirely different sized bearing.
There were some
And-
bearings which we needed a total of 44, but we had only ordered 20.
So we need to check them.
I think you know what you can do. Just connect this as much as we have, and then just quickly move to the M6012.
Yep, yep.
We can
Yeah,
have
let's-
both of them ready, so at least the shoulder is connected.
Let's do that. If before that you can check that side, maybe you might have some bearings lying around on that side of the table.
So I do have lying around for the M6012 actuator, but
We
so
don't
far
have
not.
bearings for this, no?
No.
We should add an emote of that parrot. No,
No?
one. Yeah.
No. Yes,
They might throw a
definitely.
copyright at us, but yeah,
Definitely.
we need to like. Yep, so we are unable to find more bearings, which is surprising. So that the robot might be missing a hand. It's not a big like issue.
Yeah. Did we not just talk about the bill of materials a bit early?
Yep, yep. So guys, always double check you have all the components before proceeding with the assembly, because it's like a
Yeah. At this point, I we just have to pause here because we cannot proceed without the bearings.
so
I'll
let's start the hot glue gun and let's move on to the yeah. So what's this? Yeah, these are like screws. These are M650. Let's not unbox them.
Before the glue gun. Yeah, let's first of all do the glue gun. There is also one other huge issue in this one M6012 actuator, which is related to the
What is it related to?
same issue of inserting the
Yeah, at the offset,
uh,
180-degree offset.
no not
The hex.
the hex insert. The size was different, remember?
Okay. So the size
That's
was
a huge
bigger
issue,
in
yeah.
this case.
Yeah, it's very bigger.
Yeah,
No.
we will have to drill a hole and we will have to.
No, we won't. We can just attach this on the motor and we can just plastic weld this because we know that this is permanent now. We know.
Yeah. We can.
We should
can.
just plastic weld this.
But how are we gonna attach it on the other side? How are we gonna heat it to?
Yeah, that would be an issue.
We will have to drill a hole in one side and plastic weld it on the other side. I think we can do that.
Yes, and
We can drill a hole, fill it up to the brim with the hot glue gun, and then maybe we can.
This one's gonna be a mess. This one's gonna be a mess. Let's just continue with these ones. Alright, so what I'll do is I'll start adding the motors, attaching motors over here.
Can you grab the iPad over here?
I need to, once we attach the motors, after that we need to
We need to make it really thick.
a bit more zoomed in, a bit more zoomed in. Yep.
Alright, so now we are gonna open up the motors. A lot of unboxing to do. Actually, now that I think about it, we need to have a separate. I'm gonna move all of these small bearings to this bucket over
By
here
the
now.
way, that's also really good. You can just keep it like this and keep chatting over there. That's also very good. So like sort of a multi-live stream.
Yeah,
Just
we can do that, something like that in the future. Yeah. I'm gonna move all of these bearings in here, so we're not gonna be needing these for some time. Do the other motors 6C12, do they use the same bearings?
Yep, same bearings.
Yeah, so we're gonna be needing these for those.
Yeah, I'll just be back in a second.
Now we are gonna be unboxing these motors. These are the motors for the 5010 actuator, and we're gonna be unboxing all of these. So these motors, they come in with this Apple sort of like packaging. Well, not like Apple sort of packaging, but it's like, you know, those phone boxes that you have to, once it's removed, it can be like reattached, and then you open up, you have a bunch of stickers and some like documentation. We're gonna put it back in the box like so, and then we're gonna lift this and we're gonna have our motor. So let's pull it out. So here is our 5010 actuator motor, and there are some additional things that come with the motor. You can see there are some screws. We're gonna be needing these to attach it to the actuator. So let's put these things here in the box, and let's put this motor over here, and we're gonna unbox all of the motors one by one. So I'm gonna stack up these over here, and we're gonna start placing our motors over here along with the parts for the motor. So this box is gonna be useless for now. I'm gonna put it on a side. We're gonna unbox the rest of the motors now. Let's lift the box, and once again it's the same stickers and the cushion thing, and we have our motor, and then we have these extra parts that come with the motor. We're gonna place it over here. We're gonna place the box like this, and I'm gonna move it to a side. Let's open the next one. We have 1 2 3 5 motors to join. We had 6 more to go, but we're unable to find a set of bearings. I'm not sure if we would be able to get them from Conan or a hardware store tomorrow, but we're gonna look for it tomorrow. We might have them lying around somewhere in the lab, but for now we're just rushing through this project We're gonna yeah, this one is already unboxed. I don't know if it has the motor in there. Let's check for it. It has. We're gonna unbox the motor and we're gonna place it here. Now let's put it on the side. So there are a lot more motors than what we are currently unboxing. There are a bunch of them lying around in the lab, and a lot of them are also for the lower part of the body of the humanoid robot. But we are not working on the lower part of the body right now.
How many do we need? So
Yeah, this is the last one. We have
okay,
5.
2, 3, 4, 5, 6, and 7.
Yeah, 2 of them are already attached.
The funny thing is, our robot will not have one actuator in its one arm. So it will be incomplete because we did not have the bearings.
Yeah, now
for the
now
last
that I think
actuator.
about it, we should have ordered a lot more bearings because we're gonna be building these actuators for the lower body as well.
Yeah,
But we don't have any
later
bearings
on.
for.
Later on, let's just first milestone is just the shoulders and it's standing on the aluminium profile.
Yep,
The
yep.
robot
Okay.
standing on
Sounds
the
good,
aluminium
sounds good.
profile.
Yeah, so I have this ready, and I'm gonna start applying the hot glue gun on there, and I'm gonna try to.
There's a small issue. So it right now like this it sits perfectly well, and the shaft comes up a little bit. But if you apply it too much, like this, and then you'll see that the shaft pushes it a little bit.
It's
What do we
gonna
do
happen
about that?
naturally. Like I'm gonna insert it, and then we're gonna immediately put it on the shaft, and we'll try to
alright.
keep it.
Okay,
It's like a messy but precise job.
okay. Just make sure to apply the hot glue gun on the sides and not bottom.
Yeah.
We don't want it to touch here. It should just be.
Yeah, be careful with the tip of the hot glue gun. It's like I'm gonna place it over here, but we need to be careful not to touch it. Okay, let's put it in there.
Not in the meantime, I'll try assembling the M6E12 actuator up till this point, like this snug tight.
Okay, so we have to make sure this is the right way up, and we are gonna wait for the hot glue gun to. So meanwhile, can you open these screws so I can insert attach this the right way around? But we need to make sure it's sitting the right way up, so we don't have any problem when attaching it to this part. And also there is a small guide over here. We need to make sure it's not covered with the hot glue, so it can make its way to the inside on the other actuator. I think we have a big problem.
What?
Yeah, so we needed this, but on the 2 of these, it's the wrong way around.
Why?
Yeah, so let's check. This is the right way around. This is also the wrong. We will have to now put it upside down.
Okay. We'll just quickly do that.
So
Put them aside,
right
yeah.
now, so these are the 2 screws, right?
Yep.
Okay. Let's put it in here, and let's put it in here. It would have been so much easier if the hex stand was like right, or if there was like a universal standard for these hex stands, but unfortunately that's not what we got from the online order. They need to make like a standard for the external diameter.
Can you
of the-
pass over that that to remove the supports from this one, and I'll try assembling the M6E12 actuator.
So I'm not sure about the next steps for this. So how do we attach it to
Yeah,
this
I'll
before?
not
No,
like,
no,
yeah,
the other way around.
just like this.
Okay,
And from the back side, you'll just align these four, and
where are the four like screws?
here from this.
Okay.
So the screws from this part,
Yeah.
the smaller screws, there's four of them need to go here, attaching it with this part.
Okay.
The two longer ones go here, the ones that I just gave you. This right here, this, and last one is within this heat shrinker L key.
Yeah. This here.
There we go.
Gotcha.
And once this is done, once you have removed all the, just put this back in its original box, or maybe some
Yeah, we can just
some
like put
common
it
place.
on a side.
All right.
We're gonna put them back in the box later. We're gonna deal with them later.
Tomorrow is a pretty busy day. We have UFC event on the site. I mean that's also tomorrow, but we have a lot of simple codes to do as well, related to projects, related to other aspects. So there's small tasks, many of them, which we have to do tomorrow. So that's why we're trying to sprint as much as we can right now.
Yeah.
As much as we can cover right now before sleeping to today. In the morning, it's better.
Yeah, I think either way we're gonna end up spending a lot of time during the, we're gonna probably be up till like 4 or 5 in the morning either way.
Yep. The tasks are easily that many. Even if we end up doing this live stream till 7 or 8 or 9 in the morning, I think the tasks are just too many. There's always going to be more and more stuff to do. So we'll see how long we can keep going with this sprint.
Yeah, so aligning these, it's a really difficult job now that I think of it. It's a very difficult job.
It's really precise.
Yeah, I wonder why they made it so small, this guider on top here.
This is the 180 degree difference, right?
Yeah, exactly.
Okay.
But yeah, aligning, as you can see, there's a small guide in there and there is a guide over here, but it's so small, it's so difficult to get it in there and get it the right way around, and because it's not a really good fit, it's really difficult to see if it went in the right way around or not. And yeah, either way the motor on the other side ends up moving if you rotate it. So this is one thing I would improve in this design if I had time and I could open this up in Fusion. I would definitely improve this part of the design. So yeah, now what I am gonna do is I am gonna put some hot glue gun in there, and I'm gonna try my best to make sure these guides are placed the right way around, and then we're gonna join these two parts together and let's see what we end up with. So here goes nothing. I'm gonna Actually, before the I'm gonna explain that in the next one now, while assembling the next thing.
Now there's a problem with this one. You first insert that, then we'll discuss that.
Yeah, I think it's in there. Now let me try and rotate it. Yep, it's working. So the upper part, as you can see, it's rotating. So that means the guide is the right way around in there. Now what we need to do is we need to keep it together because of the hot glue gun. Of course, if you don't have to deal with the problem with the hot glue gun, you're like pretty lucky. But we got the wrong parts and we have to deal it this way. But after that, what you need to do is you need to keep it tightly held together, and you can grab the M3X60 screws, and we are gonna start placing these screws.
Make sure they're aligned well.
Yeah, we need to align these parts. So this one, and then we have these brass inserts on the bottom. We need to align these three sections. So I am gonna align the I have aligned the bottom too, and then I'm gonna rotate the top part and make sure it's aligned, looks about right, and then I'm gonna pass a one screw through, and I'm gonna make sure it makes its way all the way through down to the brass insert, where it's gonna grab onto that brass insert on the bottom. So here, as you can see, it's going in nicely. On the bottom we also need to have it aligned. Once you have aligned one side, it's easy. The rest of them pretty much fall in place by themselves, but you have to make sure this one section is aligned. As you can see, you are able to see a little bit of that screw. You need to rotate the bottom part so that the screw find its channel to pass through, and as you can see now the screw is all the way in there, and it's gonna grab onto this brass insert on the bottom side. Now what we're gonna do is we are gonna place 4 more of these screws on all sides. I'm gonna place them here.
Here's the plus screwdriver.
We're not gonna be using that. Actually, we're gonna be using that automatic
Okay.
machine.
Good. That one is such a beast, by the way. Where's the machine? It's like
It's yeah, it's here.
like a dinosaur.
Yeah, we're gonna be using this dinosaur to screw them in, but
the voice is too loud.
it's really powerful. So you need to be careful if you have a big equipment like this. Normally, it's if you have a lab like this, you probably will have a what do you call it, less torque version of this thing. This is such a time saver, and it's also sometimes the tolerances with the 3D designs, they are really tight, but in that case this thing really pushes the screws in there and makes sure they are, once again I'm moving in a diagonal direction. I don't want to move sideways, otherwise the pressure is gonna build on the other side and you might end up breaking these walls of on the 3D printed parts. So you need to make sure you are moving diagonally when assembling this, and you need, if you're using an automatic equipment, you need to make sure not to overdo this. It's really easy to overdo this and break the part. Once I am little bit comfortable with the design, I am gonna do little by little, and I am gonna make sure everything is snugged in and rightfully in place. You know, out of all the actuators I have built so far, this is the one that has perfectly snugged in from all sides. And do you know the reason for this? What the reason for this is? It's because the channel or the guides, they ended up going perfectly all the way through. So this is like the perfect
Actuator. You can try rotating the motor over here and see it moves so little. So like it has a lot of torque.
Yes, so this is because of the really high reduction of the helical gear that we've put inside there.
Yep. Cycloidal gear drive.
Yep, now someone has to open up these parts and reassemble
So this
them.
one is also done. With this, these three actuators are assembled.
Yeah, they look really nice when put together. These are what's gonna be in the joints of our robot. So all the joints, you know, we need to make sure to add this one to the shoulder. Like these ones, I assume they don't have the perfect alignment inside for the channel, so we need to make sure we can maybe add a little bit of marking somewhere here. These are gonna be used in the limbs or the not important parts of the robot. We're gonna be using these in the shoulders. The ones we make sure have the right alignment in the channels. We have one more to go. After that, we
So
are
in the
gonna.
meantime, I'll open these one up and correct their
please do so.
orientations.
Yeah.
I'll just take this one aside for now.
Yeah, I'm gonna place the dinosaur to the side now, and I am gonna apply the hot glue gun on the next one. So this is the next motor we are gonna insert in this actuator. So I am gonna open up the screws that came with the motor once again.
Yep, this is off. It's totally in the wrong direction. So what we need to do?
Yes,
So this is a long one and this is a short one.
Okay, gotcha. So we also got one heat insert thrown out of the box over there. We can just ignore that. I am gonna be careful not to misplace these screws because we're gonna end up using all of these when joining this actuator and the motor together. Once again, these are the 5010 actuators that are gonna be used in the shoulders, the elbows, and the other parts of the robot. And the other ones are the 6E12 actuators, which are way bigger than these.
Yeah, the chest of the robot, as you can see in the image right here, over here, it's just basic aluminium profile. So like a black colored aluminium profile square cube structure. That's going to be the chest of the robot or the support structure to which the arms and the legs are going to be attached. We have aluminium profiles for that. First of all, we're working on building the actuators for the arms. Then we'll connect the arms with the aluminium profile.
Yeah, once again, the parts, the hex stands we got were totally off. This does not fit in the design. As you can see, there is a lot of play in here. It does not hold on to the 3D printed part, and we're gonna fix it the way we have been fixing it, which is by using the good old hot glue gun. So I am gonna carefully apply hot glue around this section of the hex stand, and I am gonna put it in there. And sometimes it just refuses to go in. You have to apply a bit of force, but you have to make sure it's the right way up, otherwise it will ruin the entire design for you. You have to make sure it's the right way up when putting it in there. So yeah, it looks so far so good in my case. And now I am gonna attach this part to the motor. So I'm gonna be using 2 screws. We have to use 2 screws for the 5010 actuator. need the L keys.
Okay.
And I am gonna insert them now.
Okay, so this was the culprit. This part went in the wrong way. So I'm gonna correct this now. Make sure there's 180-degree difference, and then just put it.
Yeah, it's just joined the wrong way around.
It is joined the wrong way around.
We
yeah.
will have to open up
I'll
these
open-
parts.
I'll have to open this up a little bit
Yep.
more.
Yeah, so if you can grab a screenshot of this part when it's the right way around, so we can add it to our video later on in the playlist, because this is like really important stuff.
Like this. By the way, we're gonna be showing screenshot of the wrong side, and people might think that this is the correct way.
Yeah.
They're watching at 2x speed. And
Yeah.
they're seeing
Yep.
that this is the correct way to do
Yep.
it.
We will have our live stream playlist up in like 1 to 2 days, as soon as the upper body of the robot is finished. So anyone using that playlist to build this robot will have the right information. And we are gonna be mentioning all the pitfalls that we faced while building this robot, especially with the bill of materials, because there's a lot of stuff that you can get wrong when ordering parts for this robot. And also some of the standard parts that are mentioned in the bill of materials, even if you order the right parts, depending upon your manufacturer, they're gonna be like wrong, and they're not gonna fit perfectly in the design. So you have to make sure to find your way, snuggle your way around those problems when you're building the robot.
I need to make sure this part is perfectly aligned, which it currently isn't. There's always issues like this which you can run into while building hardware products, and it's just part of the process. Iterating on the design, making mistakes while building the product, and just adjusting. It's just part of the process. And one part of the process which you need to keep in mind when setting the timeline for hardware projects. So if you have a really optimistic timeline, like in our case it was 1 week, you have to factor these sort of things, because these sort of things always arise while building projects. Minor issues, small things where you need to go back and fix some things in the design or in the assembly. Okay, here we go. It seems correct now. It seems good, aligned well, and it's rotating as well off the center. It's like the old telephones. So dial in a number 00170.
0900786601. Telephone.
So now it seems correct. I'll just snap this back into the design, making sure there is 180-degree offset between both of these. Alright, like this. Just snap it back.
Okay, now I am once again moving to the make or break part of this assembly. So I'm gonna be putting some hot glue in there, actually a lot. The more we can put in there, the better. Okay, now let's align it perfectly.
This is also one of those things, the one thing that we're doing with the hot glue gun. It's it's not the most standard procedure while building this robot, but because the parts that we have are not exactly according to the dimensions that are required, we have to use this workaround. And with these sort of things, like this, using this hot glue gun, as well as with soldering, wiring, you get better with time. So like the first one, like building these actuators first time, we spent a lot of time, but once you get the basic idea, you can just keep doing more and more and more and more. You can do sprints with that.
Yep, so once again, once you have gotten a single screw aligned, it's easy to get the rest of them in place. And we are using the M3X60 screw because as mentioned in the bill of materials, the M3X55 ended up not working for us, so we are going with a slightly bigger size. Once again, you need to make sure to go diagonally with these screws and not to overdo it. It's a good idea to have it slightly loose rather than breaking the whole thing altogether. Yeah, this one is also not my best work in terms of like the assembly. This one was like pitch perfect.
By the way, question for the chat: are you guys working on any tech-related project, either in software, maybe web development, or IoT, robotics? Are you guys working on any project, or is there any project you would like to work on? Because in our case, we're working on these projects pretty much all the time. It's pretty fun. We enjoy doing this. So I would love to know from the chat, the people who tune in to these kind of videos, if you guys are working on projects or you're studying at the moment. This time the orientation has been corrected. You can check from here and also snug it back in.
Yeah, I'm working on the next motor, so I'm gonna use attach it to this one once you're done. Be careful with this hot glue gun, like the nozzle is really hot and it's really like
dangerous.
And it's like really big. It's really easy to get your hand stuck with it.
There we go.
Easy to get bit by the hot glue gun. Yep, so it looks right now. So we're using a lot of hot glue in these hex stands, and it's not the most ideal way to approach it. If we had a bit more time, the correct way to do this would be to modify these 3D printed parts in Fusion 360 or some other CADing software, but
that would have really helped us. Because the parts would just naturally fit in together.
Yep. But when you're short on time or when you're in a clutch,
usually with projects like these, you really have to sprint because the timelines are short. There's many people involved, and there's many aspects involved to the project, like procurement takes time, and then assembly, and then presentations and all of that. So there's a lot of things involved with these kind of projects, usually the ones that we're working on. So this one is done. This is the bearing for this one. You can you're placing these parts here. You can place this one as here as well.
Yeah, have you attached bearings on there?
On this one, no. So like you can assemble it right now.
Okay.
It just needs to snap back in.
Yep. Like, let me first attach this part over here, and then.
All right, time to fix this one. So if there's a single anyone watching, this is incorrectly attached. So like mistakenly we have put this part in the wrong direction, and we need to open this and fix this. These are done correctly, these actuators, but these two are yet incorrectly, so I just have to open them up, change their orientation, and then they'll be ready to attach with motors. So this one, first of all, I'll just quickly open this one.
I'm gonna attach the bearing here, and such a satisfying sound, always snap it. And then we're gonna attach this part, and once you rotate it the correct way around, I need you to grab take a picture of this so
Okay,
we can attach it.
alright.
And I'm also gonna take a picture of this after this. Let me align everything together. Okay, everything is aligned on this side. Let me take a screenshot really quick so I can put it in the video, so anyone building this has an idea of what to do.
Oh, so you've already taken a screenshot, so that's correct.
Yeah, but
alright,
yeah,
for even
this
for
stage
part,
as
okay.
well. Now once again, but before that I'm gonna attach this to the motor. Okay, guys, don't ever lose your screws. It's so difficult to find them. Sometimes they just disappear in a separate dimension and they return after a while.
Unscrew this.
I am waiting on the L key.
Okay, you can have it because my parts have opened up. Alright, with this I'm just gonna open this up.
Yeah, you can take a screenshot of this and we can mention it's the wrong way around.
Okay.
Sorry for that. Today as well it's really cold and it has been raining the whole day over here. But yeah, the weather is generally getting more cold as the year
The weather is
progresses on.
beautiful outside. I just went out and looked at the moon. The moon is really beautiful tonight. Alright, there we go. So the part, I'll also take a screenshot of this one. This is the correct orientation. Okay, so we can have a maybe side by side image of one tick and cross. And now we need to add this part again.
So when you're applying hot glue gun in there, you need to be careful. I'm gonna be pushing hot glue. If you are doing this by using hot glue, you need to be careful not to apply any on this bearing over here. It will choke up this bearing and it's gonna make a mess out of your actuator. So you need to be careful to only go in there and leave some hot glue in there. That's what I am gonna be doing now.
By the way, chat, you can leave a comment if you want. Here we want to test something. There's a small character that appears at the bottom of the live stream. So most likely if someone sends a chat, we're not sure of it yet, but most likely their chat will appear just like this character at the bottom of the live stream. So if anyone wants to try that, you're free to send a comment.
Yeah, we just implemented this feature today. Right now there's just one lonely character.
Yeah, and we don't know if it works perfectly well. So we'll be able to see if someone sends a chat.
I think this went in the wrong way around. I will have to double check it. So it is the right way in there.
By the way, this live stream is one of the coolest ones on the channel yet. If you can see the whole image, the way actuators are being built,
Yep.
this is one of the most coolest ones.
Yeah, definitely one of the better looking live streams.
Yeah. So in the first live stream, we were just soldering wires. Nothing special about that.
Yeah.
Setup. It would be interesting to see after a couple of months if we come back to this. Our setup will most likely have changed, as well as the audience and whatnot. It will be interesting to see these initial first live streams. This one is also done. This one also done. This one also done. Alright, this part is the orientation has been changed to the correct one. I'll just grab this. It already has a bearing inside of here, and I'll just put it inside here and snap fit it. Right, that's the satisfying click sound. So this one went in perfectly well. Now we're gonna grab the other bearing.
Do we have a
part
board?
and
I think I can use this.
just place it here. There we go. Perfect snap fit, and the orientation that was incorrect before is now correct. So for reference, these are two side by side. You can use this as well if you can take a look. So this is the incorrect one, and this is the correct one. So we're gonna have to open this one and make it correct as well. So this one is ready for the motor assembly. I'll just put it over here, and this one remains. We'll just quickly open this to correct the orientation. Alright, bearing part. Take this out as well. Open these. This one. Now this one.
We're gonna be needing more of these, and so these are the M3X. No, these are the 55 ones. We're gonna be needing more of the M3X 60
ones.
Yeah.
Yeah, we just bought them today.
Yep, I'm gonna have to go grab them.
They're just right here. I can. Yeah, they're right here.
Can you like grab them? So this is the stuff we got for the project today. We're not gonna be using everything today, but what I'm looking for right now is M3X60 screws to attach the motor actuators together. So here you go. So I'm gonna be unboxing these and using these right now. So it's like opening a deck of Pokemon cards, but a really boring and mundane parallel universe version of that. Imagine if kids enjoyed this stuff. Even I don't enjoy it that much, like compared to Pokemon, of course. But imagine if kids enjoyed this stuff instead of Pokemon in a weird parallel universe reality. It looks so cool once again when put together, like a really futuristic cyberpunk sort of a module. I'm gonna put it. Let's make sure to walk in parallel when screwing these edges. Yep, this also looks like one of the better assemblies yet. Yep, this is one of the better ones definitely. So it's rotating perfectly when rotating the motor, and there is almost no clearance on all the sides. This is the best one I've made so far. Yeah, definitely. These three are not that good, but they'll also do the job. I'm gonna put these over here. Let's prepare the next one. So I'm gonna have to
This is the
unbox.
next one, yeah. It's ready.
Yeah, this one is ready to be assembled. It's like 2 a.m. in the morning already, and we haven't even moved on to the soldering part yet.
We haven't even moved to the MC612 actuators,
Yeah.
the bigger actuators, which is this one. I mean, just compare the size of these two. So this is the bigger actuator, the right one, and this is a smaller 5010 actuator. So we haven't even moved to the MC612 actuators yet. There's a lot of work to do, and we don't know how much we're going to be able to cover in tonight's sprint. Ideally, if these 7 actuators are finished, and ideally if these 7 actuators and the 2 MC612 actuators are finished, that would be a huge win for us, because then we'll be able to move to the aluminium part, aluminium profile part finally, and start assembling the arms of the robot, which we can easily do in a couple of hours tomorrow as well. So I'll just
Once again,
fit these
we
ones.
need to be careful with the hot glue stuff. And we need to put it on here like so, and we need to attach the 2 screws, the 2 small nudges. You know the character Neji in Naruto? Neji in Japanese means screw, so this is what they've named my guy. They've done him dirty in multiple ways. Not only did the poor guy died while protecting a clone of Naruto. It was not even the real Naruto.
Well, too late for spoiler alert.
Yeah, he's not like it's not like a main character, but they did him dirty in multiple ways.
Okay, so I'm gonna snap fit these. Okay, this is done. Then I'm gonna snap fit this upper part here. and this is finished as well.
I need one more of this unit, so we don't.
We do have here.
Awesome. So let's assemble this. I'm gonna
We
be.
still have many units.
Yeah, we're gonna be needing one, two. Yeah, one more.
One more. Okay,
Yeah,
here
for
we
this.
go.
Meanwhile, I think you can start working on the bigger actuator, the 6012.
We have 3 concurrent viewers. Guys, if anyone can leave a comment, we want to try something. So there's a character at the bottom of the screen. You can see a small character moving. So we just implemented this today, and we're trying to figure out if someone sends a comment, if the character and comment appears or not. So if anyone wants to leave a comment,
Yep, it would be really helpful if you can help us figure it out. It's also going to be the first comment in any live stream that we've done ever.
Yep.
So you could help us figure it out and be the very first live stream comment on this channel.
In the meantime, now, shall I start removing supports from the hand parts? But that's an easy job. I think that'll only take like
Yeah,
5-10
there's
minutes
not like yeah.
to cover
I
it
think
up.
you can have a look at how the encoders are oriented and placed, because we need to attach the magnets to the motors using the
Like
whole.
which task do we want to do first? I think before that, first of all, we should also finish the MC612 actuators.
Yeah, definitely.
And the difficult thing about MC612 actuator is this part. So this has been opened up.
Ah.
Yep. And it's already too wide for this hex stand. As you can see, it's loose. But we can put in hot glue like the early on.
Yeah, so the magnet,
It will be-
the part for the magnet is that on the opposite side.
Yep,
on
that's-
here?
Yep, that's
On the
here.
shaft. Okay.
Yes.
So, gotcha. So,
Ah.
so yeah, I think we're gonna have to go with the hot glue gun. We won't know for sure once we try doing that. Yeah. So the good thing about is we can always 3D print more parts. We can always get more
like
of these
I have
extents.
more of these parts 3D printed.
Yeah, so
But
it's the hot glue stuff we are doing right now. It's non-destructive for the. It's non-destructive for the motor, so we can always use motor in other 3D printed parts if it ends up not working the way we want it to work. So once again, this alignment, I don't know why in the world they made it so small, but yep, it's I think it's the correct way around. What we need to do now is attach screws to this. So I'm gonna grab, first I'm gonna make sure to align everything. It's a bit difficult to see, but there are a lot of holes throughout this that we need to align. Yep, I think they look aligned. They look aligned now, and so I'm gonna grab this screw and I'm gonna try to make its way through the entire assembly. Okay, it's gone all the way through. So we're gonna do the same now for the rest of them. They are all also pretty much aligned. You only need to like really work on aligning one of them all the way through. And yeah, this actuator is also almost ready. We're just gonna now go move diagonally. We're gonna move slowly, and it has been attached absolutely perfectly. Yep, I'm really loving how this one also turned out. In fact, this is not even a recency bias thing, it can't be, but this one is also perfect. It's like sitting flush on all sides.
And does it rotate well?
Yep.
Really nice. I love the motion of these with the BLDC motor.
Yeah.
It's so amazing.
So
How-
we're
how
gonna
the power
place
is
it
transmitted.
over here as well. These three are like almost perfect. These three are like kind of so and so. Like these designs can be improved. You know what? We can also try opening these up if the hot glue gun has not like. I think we can try and melt
It's
the hot
okay.
glue gun.
They do work, so that's okay. They are working, which is important.
I am gonna move on to making the last one now, and then I think we can move on to fixing the 6C12.
Yeah, that's gonna
Actuator.
be a huge. Like, that will require some effort. The thing with MC612 actuator is that this part is too small for our bearing. There's something interesting.
I think
though.
yeah,
There
I
is
think
something-
I think the best thing we can do is absolutely we need to keep this guide, this one, we need to preserve it, but the rest of them we can just melt a big hole and we can throw in.
No, I think I have an idea.
So
I
it kind of is destructive for the shaft of the motor.
Yep.
If we
I think I have an idea.
we have to be really careful.
I
with
think
that.
I have an idea.
Mhm.
I have an idea. So like, we can try adding this with the hot glue gun over here. So like, this one is a bit more close size. It will stuck. In fact, it's snugging perfectly even without hot glue gun.
Yeah,
Almost perfect.
it
yeah.
is.
And it can go in this as well.
But I don't know how much distance there's
It's,
like.
it's rotating it perfectly.
Okay, we can maybe.
That could be a. So let me try doing that. Do we
How
have these
many
extra?
more do we have? We have 3 more of these.
So we just need 2 for this. So 1 for this motor and
Yeah,
Two for
two
these.
for these. And if we end up
barely
finding,
have enough. So
yeah, we
let
barely
me-
have enough of these. We're gonna have to order more of these. But yeah, let's. I need one of these for like 5010.
For 5010, this is the small one. Yep, this is the one.
Okay, I'm gonna. This is the last one, and let's go ahead and do this for the 5010. We are working on the last one. It's the last
And
leg.
if we end up making the MC612 actuator as well and assembling even a little bit of aluminium profile, I would be so satisfied with our progress tonight. An image of an aluminium profile and shoulder and hands, arms of the robot would be so amazing
Yeah.
to see. So I'll just put this part aside for now. I'll
If I can get the L key.
Yep. I'll align this one.
Yeah, so I need one more of that bridge thing. This one, this part. Where is it?
We have one here. Here. Oh, not here. We have one here.
Oh, okay. And let's put this one. This is the last actuator that's small, that's 5010, at least for the upper body. For the lower body we have a lot of motors just laying around, but I don't think we're gonna be working on that anytime soon. Let's try and put this thing in there. Just 1 second. Okay, there we go. Alright, there is a slight looseness in this.
Slight play.
Very slight.
Yeah, I think
glue gun is just gonna do wonders. But on this side, if we test it here, there is not that
yeah,
much
but
play.
I want you to try to, without the play, I want you to try to snug the whole thing together. Is it the length, is it enough?
Try.
Is it, yeah, is it gonna like go all the way
Try.
through both of those holes?
Okay, so for even for this one, we have to follow the same standard procedure. Oh, danger.
Abunai.
Abunai.
Oh. So, you know, after assembling quite a few of these, I have learned like a few tips and tricks to really snug it in perfectly together, these two parts especially. Yeah, ideally we should not have had to use the hot glue gun anyways, but guess we had no other option. So that's what it's something that we have to do to get this thing working really soon. Yep, it's perfect, looking perfect already. I'm gonna place it this way around. I'm gonna put the hot glue gun to a side. So just need to quickly confirm the parts for MC612 actuator because they're different from the 5010. The screws which need to go inside of this one are different, so I'll quickly just confirm them from the bill of materials. One down, M3X30, and that is over here. These are M3X30. I'll just grab a few of them here and put them here. So the last one, this is the last one we have to assemble, and this is also perfect in terms of like the assembly. Everything is nice and tightly snugged in together. Yep, so the 4 actuators here, they are absolutely perfect. So now I'm gonna place them like here side by side. So these are absolute perfect, snugged in tightly parts, and the remaining ones, these are not the perfect, but they do the job. They're like the motor can rotate these actuators.
but we might have to open these up if they don't end up behaving as expected.
Yep.
Yep, but now I want to apply the hot glue gun with this so we can figure it out.
Yep. So I just need to.
You can bring in the material for the other six
MC612.
Yeah. So
okay, so like you can carry on doing this.
yeah.
I will also
do
give
that.
you the other bearing.
Yeah, you can actually see the size difference between this and this one. Like this motor is so much bigger compared to that.
I think this is the other bearing for this, and this is the part which goes up on top,
Okay.
and there's already one over here. So all the parts are complete for this one. I'll just bring in the other one, and we'll see if we can assemble that quickly as well.
Yeah, these screws, they need a bit of working. They need really need to push while rotating them to get them in there. Otherwise, I don't know if we no, I don't think so. We have the
Once
parts
again,
for the-
a small detour. There's no brass inserts here. Small detour.
You can just
Just quickly do that.
grab them. Yeah, I'm trying to see if we have a part that we can use to rotate these. Actually, this one is perfect. So yeah, this is gonna save us a lot of time now. So I'm gonna detach this from this dinosaur, and I am gonna put this part into this dinosaur over here. And now our speed in terms of like screwing and unscrewing, it's gonna be at least 10 times fast.
I'm gonna put on the soldering iron, so just
Yeah, they are coming out a bit on the other side.
why?
Yeah.
It's fine. It's fine. I saw it in the video as well. There's no issue. I saw it in the video as well. There's no issue.
Yeah, we also need to make a video on the assembly of these actuators. So for the next one, make sure to do everything in the like center
Okay.
part over here. I'm gonna leave this all the center area to you.
Okay.
So we will be grabbing some clips from this live stream for that.
First of all, the brass insert.
It's like not going in there. It just refuses to go in there. I don't know what's wrong with this screw. The rest of them are going in perfectly. I think I will have to change that screw. Yeah, these are the ones I think. Let me push this. Yep, it's gone all the way. Yeah, so that saved a lot of time, and this is for the bigger one, as you can see, and it looks so cool as well, like when put together. Someone has been watching our live stream for like 4 minutes now, or at least he's brought the average view duration all the way up to 4.
Yep.
So thank you for watching the live stream for such a long time. And I would what is the right way to put these if we want to keep this area exposed? What's the right orientation to
Yeah,
put this?
that is the right orientation.
Yeah, but they're not going in. Did you put them at 180 degree offset?
Yep.
But they're not
At least
going
I
in.
tried.
Yeah, they're not going in, and I think we need to.
Now they should snug all the way in. It's very.
Yeah.
You try. No. There's no need to for
No, I'm
apply
not.
too much
I'm not
force.
like forcing them, but yeah. Are they even at a 180-degree offset? No, I don't think they are.
And this is the exact issue I had with the actuator last time.
With this
one,
actuator, yeah, I'm gonna like try.
Disassemble and just make sure everything is perfectly
Yeah.
correct.
So imagine if we did not had this dinosaur to unscrew and screw everything together. It was one. It was gonna waste so a lot of time if we did this using the LT all the way. Shout out to dinosaurs for saving us time. Last one. Okay, and now I am gonna remove these, and I am gonna remove this. I'm gonna put them at 180 degrees, and then I am gonna try and push them in there while trying to maintain that offset of 180 degrees. It's a bit difficult to do. I think it was right.
It was okay.
Yeah,
right?
I mean, it kind of was okay, but
What seems to be the issue?
I don't know. Let's try like once again. Instead of screwing it, adding the screws, I'm gonna try to push it in here once again.
I think is that enough of a snugging in? Check on the other side.
No.
Hmm.
So for some reason these actuators are not going all the way in like they are supposed to, and we're still trying to figure out the issue with these. I think we are gonna have to play a bit with the offset. I think let me try and make the offset 0.
It's really strange. They should go in perfectly well.
Okay. I think I found the right. Yeah. It's going in there now. Let me lock in on this location. So it was a bit of a challenge to find this orientation. So I'm gonna make sure not to lose it. Why is it not sitting in there? Okay, it's sat in there, and let's try and push it once more through here. And yeah, it seems to be working perfectly now. In fact, I'm gonna screw it while it's in there just to make sure there's no issue later on when you need to move it to the center so we can have a video for later on. You can. Alright, 3 more to go. M3, and then we need to add a bit of M2 as well
4 M2 hex inserts.
I think it looks perfect now, right?
Yup, this time it's perfect.
Let's go.
Was it 180 degrees or 0 degrees?
I have no idea. I just kept trying random
Interesting. So
orientations. So this is the first perfectly assembled 6E12 actuator we have got, and you can see the size difference from this to this. It's like a huge difference between the two actuators. And we are gonna be building two of these to use in the upper body of the robot. And yeah, I think we're pretty close. We just need to do some soldering or welding, plastic welding to insert the brass nuts in there. Once the brass inserts are in there, we can put everything together.
Yeah, in the meantime you can attach this inside of here and try to attach it with that.
Okay, so everything is ready on this side then.
Yeah, everything is ready
okay,
for
okay,
this one.
gotcha. Okay, wow, cool.
And after this we can, once we have both of these actuators ready, we can really quickly put magnets on all of the motors and screw the encoders on all of them. That will I think hardly take like 20 minutes, 20-25 minutes only.
So once again we are using hot glue gun for fixing this as well, and it's interesting the way the channels for this one and the other one are exactly the same. I'm gonna put some hot glue gun in there. If you can take a screenshot of that, it looks like a really
Or
just like a screenshot. Enter. Awesome.
we sort of have a studio setup in our lab now as well. It's like a standard studio setup. Whenever we're ready we can just push the buttons and the video is on. And that's kind of ultimately the goal.
Yeah.
Like sort of have a studio as well. So because of the hot glue gun, it will be almost impossible to disassemble these actuators.
Yep.
How hard is the hot glue gun connection?
I think we
Is it
can
like-
rip it apart if we like really want to. I don't think it's gonna be a big issue ripping it apart, but it's pretty solid. It's really up there in terms of like
Rigidity of the connection.
yeah. Okay, and
Enter
I think it seems good. Just a few more connections, screws to go around this, and I think we should be good to go with this as well. I am gonna spend some time, move it to the center while building it. I'm gonna spend some time aligning the screws. Okay. Even the 60 is having a bit of a hard time going through these. So right now I'm trying to once again align this for the 6C12 actuators, and in case of these actuators it's way more difficult to align everything, so you just have to kind of move everything around, and once one screw is in there it's way easier to align there and insert the rest of the screws. So I'm gonna try to go diagonally here on the other side, and it just went through as well.
Once the brass inserts are added on this part, I think we'll assemble the rest of the actuator pretty quickly. So we'll have two M6C12 actuators and 75010 actuators built. The reason why we cannot assemble more 5010 actuators is because we do not have any more bearings for it. So for now we'll just assemble these actuators that we have.
Yeah, so I think I ended up using all the 60 3x60 we had.
I don't think 3x60 are gonna go inside of this. There'll be different ones. You should check from the BOM.
I think
Check at least once.
no, I think they are kind of making their way to the bottom. I doubt there will be smaller ones for this.
Let me verify. So there's
So
oh yes, it's same M3X55.
yeah,
That's
and
the same, yes.
60 is barely making its way like all the way down.
Okay, that's
And
it.
yeah, I don't think we have enough 60 to go around even.
Around where?
For the second one, so we're gonna run out of it in the process. So we're only gonna use few. Let me check
Okay,
if we
then.
have enough. So it's gonna be like tightly
would-
fit together, but it won't have all the screws in there.
Okay.
Yeah.
We're really short on parts. Chat, we're really short on parts.
This is
At
M4.
this point, like the bill of materials or like procurement of parts is holding us back from assembling all of this.
Yeah,
really
whenever
fast.
you are building, oh wow, taskata. So I just found these lying around in the lab, and these I think are the exact size that we need. Yup, right now. So it's a big lifesaver to have these things laying around in your lab. It was gonna be a huge problem, especially for the other actuator, if we did not had enough parts. That was like totally unexpected.
Yeah.
So now dinosaur once again for the clutch, and I'm gonna be using dinosaur to make everything formal and ready. So let's start. Yep, so I think we will have to hold it like this. Ali, I want you to
Okay. Just a
fasten
second.
these.
Okay.
Yeah, I think even, yep, like this. Is it holding on? Keep spinning it. No, it's loose, right?
Oh no, it's going in. It's going in.
Okay.
It's gone quite in.
Yep, okay. Gotcha. The second one should work as well now. Yep.
Yeah, be careful. Be careful.
This thing is an absolute beast. Guys, we have our first 6C12 actuator ready, and it's working. It's making some weird noises.
Just aside from the noises, is there any resistance to the motion?
No,
Then it's perfectly fine because the parts are clanking together.
yep,
That's
but
not an
yeah,
issue.
this is the
These,
first big one.
Do these also make noise?
No, these are perfect. Like, I've been rotating them like.
Okay, so where are the bearings aside from these ones?
They are all in here.
Oh, okay.
Be careful with the like hot glue gun. We are gonna be needing this for. Okay, where's the second motor?
Got it.
Is it? I got hot glue on my. Yeah, so we have to unbox it.
Yeah. MC612 actually.
Yeah, C612. So this is the bigger motor. Let's unbox this. We're gonna go and so it will probably also have a bunch of stickers in there. We don't need those. This foam thing, and here we have the second, the bigger motor. I'm gonna place it here, and we are gonna grab these goods to attach it to the actuator. Let's safely store this box somewhere. I'm gonna put it there. I'm gonna make sure all the parts are accessible. So if you go back to the like start of this live stream, you can see this setup was looking really neat, but once again it has become a mess. So always before starting the project, we have to clean the entire space once. Otherwise, over time, the mess keeps piling up, and it becomes really difficult to work on anything. If you like have ever worked on hardware projects, you know exactly what I'm talking about. So this is for the CMC 6. This is C612, and we need to use
What
it.
do we? Just keep it in its box. Keep it in its box.
Okay. Let me see if. You're barely in the corner of the screen there.
Okay. Second layer of bearings to add. Black color, black color, black color bearings. Okay. By the way, inside of all of these actuators are these small little bearings responsible for such smooth rotation, along with the cycloidal drive mechanism. I'm just gonna grab this one. Alright. So we have the bearings and spacers inserted in the part. Now next up we have to pick the two discs, which are over here, and add bearings inside of these.
Yeah, they're gonna be the same bearings.
No, I don't think so.
These ones.
Let's try these. Oh yeah, they
Yeah.
are the same. They are the same.
So a lot of the design DNA is the same for both the actuators, the small one and the bigger one. The design DNA is pretty much the same. You only have to play around with different sized screws and different sized assembly for these two. Otherwise, most of the DNA is same. Dinosaur coming in with a clutch.
I can't believe we have M6C12 actuator also ready. I thought this one would have taken a lot of time.
Yeah, the only design wise weakest link in this is definitely the hex stand, because if I don't know how the hot glue will hold up if there is a lot of torque on this joint. I don't know how it's gonna hold up. Let's attach this in there, and okay, it just came off once again.
And disassemble and reconnect.
Damn it, these bearings. Okay, and let's try to get it right this time. So I'm gonna push on the bearing, and yeah, it's now perfect. Now comes the tricky part, which is like putting it.
Nah, that's the wrong direction. You have to put it like this.
Okay. Yeah, so that was a mistake we were making. Now comes the tricky part, which is like putting everything we have made so far in there. So if you can bring in this part.
Yep. Does it go all the way in?
Yep. So got it on the first try.
So let's grab a bearing from there.
No, before even bearing we need to attach screws. So yeah, this part, let's put it on there, and we need to lock everything in this orientation. First no, I mean this orientation is already fine, and let's try and put it over here. Yep, and then I'm gonna use
these.
I'm gonna change the head of the dinosaur, and
Can you put these back so that way everything's clean on the table? I think our table will be pretty clean even after we're done with this. because only the actuators will remain.
Yep, this
And
this
it's
hot glue gun is live.
Okay.
I'm so ready to get turn it off. Like, it's like the most unnecessary thing when building this robot, and we, if everything went smoothly, we wouldn't even need it. But and it's also the hottest thing on the table right now.
Right. Two viewers at this time, two concurrent viewers at this. This live stream setup is interesting enough to grab, to build some interest.
Yeah,
to
currently
anyone
there
of
are like
it just
concurrent-
dropped right now. There were two.
yeah.
So this
Okay.
this one is perfectly fine. Okay. Now we can
Yeah,
start
let's
pushing it
let's
inside.
push it in here, and let's put it in there.
Alright, so there's an issue once again.
It's not going in. So yeah, I found the fix for this. So I'm gonna remove this bearing. We are gonna first insert this, and we're gonna make it pass through here, and then we are gonna insert this bearing. So now it's already like in there. So that's like a hack.
Yeah. Okay, but make sure it's
Correctly in its place, not too below or not too shallow. It's not like rotating even now. Let's push it out. First up, let's make sure this thing is in its rightful location, and it's not like fighting with the, yeah, it's able to rotate in there. It's able to rotate in there. Then we can put a bearing first on the bottom side.
If it's going in there right now, it should go in even after inserting the bearing.
But let's try and fit it like this on the bottom side, and then we can make sure it's flat, which it is not right now.
So okay, so that's one part. It's sitting tightly on this. Now we have to insert it as deep as we can. Oh, just a second.
It's not even visible.
Now put it inside. Push it inside while rotating it. So
Okay.
yep, even rotate it a bit more.
No, it's not going in there. See, it's like such a weird problem. For this one, I inserted this firstly, and then I moved on to. I think no, yeah, it's blocking the way. It's not like going in there. So I inserted this first, and then I handled the bearing.
Just make sure not to insert too much.
Okay, it's not like it's kind of in the middle now, and we need to.
You can insert the bearing now.
Okay, yeah,
Yeah, the bearing should be fit. Snap
Yep,
fit.
it's okay. It's not perfectly
The bearing or the part?
just the bearing. We need to make sure the bearing is sitting horizontally in there, and then for the, yeah, I am now holding the bearing on that side. You can try and make this part horizontal.
No, it's stuck.
It is stuck, and it won't even move around, right?
No.
So if we try to snap fit everything together, it's not gonna like work.
No. Let's just disassemble and correctly try once again, because we want to make sure this is perfectly. It's stuck really bad now.
You can try pushing it from here.
So what's the problem with this one? The phase difference between these is not exactly 180 degrees. It sort of sticks before rotating. These are stuck, as you can see. For some weird reason, these are stuck. What could be the cause of this?
These are not like stuck. They need to rotate about each other. They are not stuck at all. They need to rotate about each other.
So about each other.
Yeah, they're not. They're like perfect. I think it's gonna be a dance between making it sit in here and then trying to get the bearings rightly placed with this. So it's gonna be like a dance of managing the two. Yep, I am kind of understanding what the problem is when we are pushing this part in the bearing.
You're pushing it the wrong way. It needs to go like this from here. Let's just open this up. Let's not waste too much time. Give it to me.
Okay, it's sitting pretty tightly in there. Let's remove it, and let's try remove these as well.
Very carefully, they have the bearings.
Yep. And then we need to orient this the right way, almost, and like this. Yeah, the gap is like 180 degrees. Now what we need to make sure is it let's attach this. We can also, like I did what I did with the other actuator
Without screwing in, try it.
yep, exactly. That's
Keep
what I
the
did.
bearing in and then try it.
And then let's try and pushing it all the way through, and we have to make sure it goes in perfectly, which it is not doing right now. Like, yeah, it's a struggle to get this thing in. I do wonder if a lot of people have troubles with this actuator. Or let me try a different way. Let's try putting it this way, okay? And
this time it came more than that.
yeah, but it's in the current orientation it is right now. I don't think it's ever gonna pass through, so we're gonna have to remove this. We're gonna have to detach this once again,
Mm-hmm.
and we're gonna have to play with this offset. Let me try and make it exactly 0.
Is there by any chance issue with there's no issue with line?
No, there is no such issue.
Like this.
And let's try and make the offset as little as possible this time around. You see, it always ends up turning perfect one. Let's try and do this then.
$180 once again.
Yep, there. I think there's like only one single way it can fall in there. No matter how we twist it, it's gonna like end up in the same position. It is the wrong way around. Jeez, man. And let's try and put it, fingers crossed, I think this is gonna work this time around. Or let's let me double check.
It's the same on both sides. There's no difference.
Yeah, it's
By the way, quick update. So we have 7 actuators for the arms and the 5010 ready. We have 1 shoulder actuator, the M6E12 ready. We're trying to assemble the second one. It was supposed to assemble pretty easily, but we're facing a slight issue in alignment, so we're trying to fix that. Once this is fixed, we will have all the actuators ready.
so it has
In
gone
terms of
in through
hardware.
all the way.
And-
Yep.
okay. Will it rotate? Can you try?
I hope it will.
So, let me try.
Just a second. How are you gonna like try to
Say-
rotate it? It's gonna.
No,
It-
it's stuck inside. It's not. It's
So
supposed to
yeah,
rotate very easily.
and that's the reason it was like not even going in there. Now the these edges, these gears are really tightly snugged in with this 3D printed part.
Can I push it like this? Okay. Alright, let's try changing this part if we can.
Yes, I think this part is the culprit. Or these ones, these rotary parts we have over here.
There's other variants of this part as well, but I think there does not seem to be an issue with these parts.
They just refuse to sit in there.
There's other ones as well. We would have to completely disassemble the bearings and add these.
No, I don't. I think they're pretty much the same. I don't think it's an issue with these parts. Let's try and grab a separate part for this.
So we have the ones which came from the other 3D printer. The other Bamboo Lab 3D printer.
Yep,
not
yep.
our-
We should grab those.
Check this. Is it the same size?
Yes, it is the same
Okay,
size.
try this.
Let's try on this one.
The issue is the same.
Yes, it's the issue is the same.
The issue is there's something
It's
else.
weird. It's a really weird issue.
Is there any bearing missing or any part?
I don't
Take
think
it
that's
off.
the case.
Take it off. Take even this part off and check this part. The bearing alignment. We'll need to check the alignment of the bearings. It seems correct.
Yeah, I think it has to do with the.
I have snapped them a little bit. They're now touching each other.
The issue is exactly with the offset this thing is creating between both of these gears. I think we should. This part needs to be changed.
Okay, so like here's another one of the same part if you wanna. This one is not good. This one. Let's remove the supports. By the way, we can also grab, even if this one does not work, we can grab one from there. Where? The ones that came from the other 3D printed, the other 3D printer. Yeah, okay. It should work. It's a slight support here which we need to remove just to clean the part before it's ready for the assembly. There's a support here as well, if you can notice. I will remove this support here as well. Alright, let's try this part.
Let's attach this over here, and now,
Yeah, just make sure they're aligned well from the side. It's not too inside of the bearing and not too outside of the bearing.
yeah, I mean, either way, it's gonna be exactly same in any direction. Yeah, there is one thing we can control though. Like, let's try and do this first. I
Okay.
am gonna.
This is the part. No, opposite side.
Oh yeah.
Make sure it snaps in.
Yeah.
This is off.
No, it should not be like a big issue.
Okay.
And let's try put this on, and let's try inserting this in there, because if everything is okay, it should have no problem going in there. It is going in there nicely. Let's try to see how it will react to a bearing being inserted on one side. Yep, it's all good now. It's rotating, guys. It's alive.
Nice.
Finally.
Nice, after a long time. So
Let me first tighten everything together while it is in there and it is in the correct. It's pushed in there in the correct orientation. I think it looks somewhat.
can we try inserting the bearing first and then inserting this time?
I don't know if it's gonna work like that though, but it's
I should.
yeah. I think it's moving. We should like take advantage of this. Let's try. We're gonna screw everything together with the dinosaur. The dinosaur.
Okay.
Okay.
With that, we can just.
It's rotating perfectly in there.
Yeah. Just place this bearing on top, snug it in,
Awesome.
and now both parts. This one first of all.
Keep it in the center.
Alright, it came together beautifully.
So this part really was the issue.
Yep. And lastly, the part from here at the back side. Alright. With that, wow, this one came together pretty neat.
Yeah, it took a lot of effort. It made us struggle a lot, but in the end, it came out really nicely.
Do we have to insert any screws here?
Yeah, at the very end, I think.
Okay, after touching the motor. Have you unboxed the motor yet? It's there. This
Yeah,
is-
now we have to like do the hot glue stuff.
Okay. It's the last ones.
Yeah. This is looking really beautiful, and I'm gonna place it. So which part are we gonna insert the hot glue?
No, it's this one.
It's this one. Do we first attach?
This is the M6 actuator. Yep.
Yep. So first, let me put some hot glue onto this
Part. I was thinking first attach the.
I
It and the
kind
motor?
of messed it up a bit. No, I mean we can do that later.
Okay.
We'll kind of chill on that side. So let me put it in here quickly. It's a bit of a quick process, and then we kind of we need to press it so the it pushes it out.
Okay.
Now it's the now let it we're gonna let it solidify a bit, and meanwhile you can insert it with the nuts. This thing is like it has burned me so many times in this live session. Which screws? Yeah, I think
The small ones.
the thick ones, right?
Yep. Just check which ones are the smallest size. I think this one
The
is the
very
smallest.
smallest.
Yep.
Okay.
The smallest one.
Yep. Then these are the ones. Yeah, they are they like sitting in there?
I think so. Yeah, they will. Where's the L key? This actuator came together so nice.
Yep.
How do we go about attaching these?
What do you mean by that?
Just the exact fit. I think we'll need slightly bigger than these.
Yep, that's what I was saying. Maybe these ones. Try these thick ones. I wonder what they are for. No, so these are not the right ones. So let's try this size.
This one, right? Yeah.
Yeah, definitely these are the right ones.
Yep. Went in just the moment they saw the inner threadings. Alright. This is done. Let's tighten this up a little bit. And here as well.
Yep, so now the last step and
No, first let's attach it over here as well.
Yeah, so what we're gonna be using these screws. I think these are really long ones for this step. Most definitely these ones. Yeah, you're not aligning them right. You need to rotate it a bit so it finds its thread. Still not going in there. Let me see.
Just a second. This one's gone.
You're gonna have to rotate that and figure it out.
It's attached magnetically. Guys, this is the last actuator we are building. After this, we can start adding the encoders, soldering all of the wires, and start the assembly of the upper part of the robot. So we have aluminum profile parts which we will attach these actuators with, as well as the parts of arms 3D printed, which we will attach with the aluminum profile and these actuators. So after this actuator, we will move on to the wiring.
This just now arguably the most difficult step and the most annoying step that we have been going through during this assembly, the hot glue part. So I have to make sure the existing hot glue, it is melted and it is in like a fluid state. So and then I have to add some hot glue in here. And then I need to grab this. I need to loosely align these parts and I need to press everything in together. So hopefully, Ali, if you yeah, the motor is moving. Yep. So
Yep, just press these and make sure that the glue dries out.
I think the best way to do that is to like now start inserting these.
The screws.
Yeah, because it's the. I wonder who made the decision. Like the overall design is genius. I have nothing against the design, but the hex nut part is like so unnecessary because of the different sizes of hex nuts everywhere in the world. We need to move the bottom part. So yeah, I wonder if there was a way to make this design better by using screws like M3 screws attached from one end to the other.
or something like that. The hex nut part, just does not make sense to me. Okay, so these are coming along nicely. They are in their rightful locations. So this one should be aligned as well. Now we're gonna put in the rest of these screws. Make sure they're aligned well in the bottom as well. This one won't go through. I don't understand. Yeah, probably like. Do you have a hammer? Where is the hammer? We need to hammer this one in. The hammer is. We can maybe use this. It's like really sturdy. The hammer is here if you need it. It's going in, but it's. Yeah, I'm a bit scared with this screw because it's like it took a lot of effort for it to go through. Yeah, and so now I'm gonna like snug them in like this, and you can just tighten them. This is the wrong head. Okay, I'm gonna like snug it in. Go ahead. Push it down as well. Leave it. It's not going all the way. We're gonna try some other side. I think this one went in. This one is good. Go with this one. Oh, I don't wanna overdo it. Now this side. Okay, is it loose? Or something snapped? Yep, so they're not going perfectly all the way in there with the brass nuts inserts. You need to push them. Why is it rotating like this? Because it's free. It's not picking up on anything on the other end. You need to push it down. Not going through, right? Yep. So let's try and see if we do have longer screws available. So let's add. This is not M3. Yeah, actually I doubt if we have M3, a longer version of M3 available. We don't have one. The thing with this design is the brass inserts, they needed to be more pushed in. The brass inserts, yeah, they're like
out of it. This
So
one.
we can
Yeah, this one was perfectly
so
in
like,
and
okay, just hit the iron, push them a bit more.
yeah.
Right
that's
now.
what we need to do.
Let's I'll turn on the solder. Try that. Let's try to
We need
quickly-
to push them a lot more in there.
Yeah, do you wanna remove the
Yeah, I wonder where this design is going kind of wrong. I don't know why it's not like. If you can hold it like this for me. Yeah, tight. Yeah, from this part. I think it should go in all the way.
wait, leave it.
Mm.
Until it touches the brass, the hex nut, it's not worth it. So just push all
I
of them
think
a little bit more.
is there something wrong with the length of these nuts that we have inserted? Yeah, I think that's the issue.
It could be
It could be the issue. So we were trying with this
55.
one, right?
Are these
Let's.
55?
I don't know. Let's measure the length of these.
I think this one was already inserted.
No. This one is already loose. So let me pull it out, and we're gonna try and see the length of, because there's something really wrong with the length of these nuts or something.
By the way, guys, if you're still watching the video, if you leave a comment, we want to try something. There's a character which appears at the bottom of the live stream, as you can see. If there's a comment, we want to check if the comment and the relevant character appears at the bottom of the screen or not. So if you want to leave a comment, we just implemented this new feature. We want to test it out.
It's not gonna work. Like, we're gonna have to pull it all the way. Let's measure the length of this.
Same.
Yeah, it's 60.
It's 60, so it's perfectly fine.
So I don't
just,
know what's going
just-
wrong with this design then.
Just hit the inserts, I think, and push them in a bit more.
No, I don't think that's necessarily the issue. Because if you look on this actuator, the screws did make it almost all the way to the bottom. I think I get it.
These?
Yeah. They are not. They are
Okay.
not. This section has been.
Lift it up.
I don't want to say lifted up necessarily, but
Try the L key.
let's try and see, because it was already like really tight.
Is it that the length of our screws is wrong? Yeah, it could be. It could be that these are the screws that need to go in. Take these out.
No, these. I think the size is the same. No,
Check the-
yeah, these are wrong.
These are wrong.
No,
Or-
these are right. These are right.
These are right. Are
Yeah.
these the same? Can you?
Yeah, I think so. These are the same.
Yep. They are the same.
But I think we can, if we try to push it a bit more with the L key.
There's a there's most likely a problem.
Where is the L key?
The L key is.
I just had it right now. Guys, we're deep in the nighter and we have stuff disappearing in our lab.
The soldering iron is on. Be careful.
Okay.
Um,
LK is here.
I'm still a bit confused about these screws. So I think they might be wrong. They might be wrong. Don't try pushing them in.
No,
Oh, yeah,
I'm opening them.
Okay, you've opened this, right?
Yeah.
Just take it out. Take it out.
Yeah.
And leave it. This is the MC612, right?
Yeah.
Take one of these out. Yeah. There you go. There's the problem.
Okay, so we used the wrong set of
Put it
screws.
back in. Yeah. Oh,
And I'm gonna remove these screws now, and we're gonna put the right ones in this time. So are
yeah,
they
yeah.
this-
These are the right ones.
Okay.
Remove these as well first. Of all.
First, I'm gonna make them hold their lock in their position.
Okay. Okay. That's in a.
Also with this one.
Okay, remove these. Be careful. Oh, you're tightening it.
No.
Yeah, now it's loosening.
It was way in there.
It's too tight. This one and this one, and this time don't make it too tight.
Okay.
This and this.
Okay, and
Such a small
how
error.
is our assembly gonna react to this whole thing now? I'm not too sure. I don't know if the screws are gonna make it all the way.
You can try pushing these a bit more.
Let's first try it. Ah, so it has grabbed on the screw
Yeah.
now. Wow.
Okay,
Now
remove this one. Remove this one.
we have to insert some really thin thing in there, something really
Try rotating it. Now push on this a little bit.
push on all of them while you're at it. I'm gonna turn off this thing now. We won't be needing it anymore. Make sure none of them have a screw in them.
This one has. This one does not. Well, insert this one.
These two?
They both have screws. You need to unscrew them first.
Ouch. The brass inserts are really hot.
Yeah, these two.
So we're gonna try these two first. So we will have to push this.
No. I want you to unscrew.
Just push it, it should come out. Nope. Yep, we should be able to grab it now. And there we go, first the inserts. The actuators themselves are like taking such a long time to
assemble together, yeah.
And we have a lot of soldering to do after this, and we haven't even touched the motor controllers yet. It's gonna be like a really long sprint.
These are already attached, I think.
Yes, those are already
Alright.
attached.
There was one.
Yeah.
This one, I think.
Let's try to insert some really neat ones this time.
I'll just attach any random ones.
What is the length of this one? Interesting. So yeah. Okay, it is in there. Perfect. Let's grab another clean one. Wait. How far off is it? It's quite far off.
Why?
For this actuator, for now, let's try to hold it together with as little screws as we can, as in terms of
What's the
quantity.
gap like?
Yeah, it's like a 3D printing issue. It's not. I think if we push on it enough, it's gonna grab on the other side for sure. Yep. We're gonna try with this one as well. Yeah, it's gonna be difficult to push it. Okay, cool. Let's move on to the last one, the one that refuses to grab on. And perfect. Finally, we have this second one. Let me see if it makes that weird noise. Yep.
It does?
Yeah.
Alright.
So this is something common for the 6C12 actuator. Finally, we have the two 6C12 actuators and a bunch of 5010 actuators, and I'm gonna move the hot
wait, yeah,
hot glue gun around.
Move the hot glue gun around. So first of all, just put these nidges back where they belong. In the M6C12.
Let me find the box for that. This actuator made us work really hard. Actually, I have to turn this on again because we are gonna be putting the magnets for the encoders on these motors.
Yep, all of them one by one.
We can put it back. We can put the bearings back. We don't need this for now.
Where did the magnets come out from? Did they come out of the motors or?
Yeah, they came out of the encoder.
Or the encoders? Okay.
Yeah, so once you get these encoders, you will have these magnets with them inside the packet. Be sure to not lose these magnets. You won't be able to use off the stock, off the shelf magnets with this encoder. They have these specific magnets that are able to be used with them, so don't lose those magnets like ever.
Okay, let me just take one.
Be careful, yeah.
Just a moment. Okay, I'll edit it.
If you do you have your where's your mobile phone? Give it to me.
Oh yeah.
Picture and then maybe also video. This is better. And a video. It's not even like showing up.
Alright.
Let's
Yeah,
let's start attaching the magnets onto.
and then just attach the magnet and push it towards me. I'll screw the encoders on top of it.
Yep, sounds like a plan. We have to make, yeah, this one had already had a magnetically like attached onto it. I'm gonna pick it with this tweezer, and I am gonna place it right in the center.
I'll be
So-
back in a sec.
Let's try and grab this and put it on the center. Let's try to make the orientation right. It's perfectly in there. And I'm gonna start placing magnets on all of them, and once we have magnets on all of them, I'm gonna go ahead and start applying the hot glue on these magnets. This one is also attached. I'm gonna be placing magnets on all of them like this. Few more to go. So these magnets magnetically latch on to these parts, and you can simply just like throw them on there. They will latch themselves onto the shaft of the motor, and then you can orient them the right way around. So I am gonna, this is the last one. Then let's bring this closer to the camera, and I am gonna drop ever so slight bit of hot glue gun on there. I'm gonna drop a little bit of hot glue on it, and then I'm gonna sort of move it around to make sure it sits in nicely. If there is any excess hot glue, I'm gonna remove it by using these tweezers. So we want to make sure it does not disturb the rotation of the shaft of the motor in any capacity. I am gonna do that, the same thing for the next one. So let me drop a little bit of hot glue gun over here. We're gonna do the same for this one. And I'm gonna also apply some hot glue gun on the 6C12 actuator first, because it is different. It's a bit different. As you can see, I am gonna apply slight hot glue. I'm gonna make sure not to do it too much. And yep, that's it. That looks good to me. It's gonna solidify in a bit. We're gonna make sure the shaft of the motor can rotate. We're gonna place it at a side. We're gonna move on with the rest of the 5010 actuators. Add a little bit of hot glue gun. Be careful not to overdo it. You don't want it to hinder the motion of the motor. Yep, so this looks good. I am gonna move this one to the side as well. Then we are back with the 6C12. So to apply hot glue, we are gonna drop a little bit of hot glue on the sides of the magnet like this. Also a little bit on the top. So be careful not to overdo this. Once again, we don't want it to mess around with the rotation of the shaft of the motor. We have 2 more to go. And here goes the last one. With that, we're gonna start attaching the encoders now on top of the actuators. So we're gonna take these one by one, take this apart, and we're gonna start screwing these down
on the motors, on the actuators.
Yeah, so I think
Yeah.
how we can go about doing this is I can start checking if the actuators have any short connections because the wiring gauge was wrong, and I can start passing them on to you and you can start attaching them.
All right.
So let me prepare the multimeter.
So we would need the M2 screws, M2X6 screws.
Oh. Just that part, that part over there. This one is good to go. So you need to do this right in the center of the video because we need to make a
Okay.
video out of this for our life.
So M2X6. Gonna cut this open. These are unbelievably small. They're the exact size for this one. We would need washers as well.
Why would
This is also correct. Just
Yeah.
keep placing the correct ones here. I'll just keep picking one by
how
one.
many do 1 2 3 4 5 6 7 8 9? Okay, so I don't need to go beyond 9 for now.
Yeah, for now, no need. We're gonna place this in the correct orientation.
Let's just ignore this one for now. We are very close to like finishing the assembly part. How many do we have? 3 3 6 7, 2 more to go. And then I'm gonna be attaching them as well.
These washers are lifesavers. So the M2 screws which we got from Conan store here, they came with washers, and without these washers this would not have been possible, this joint. If you can see very closely, the holes for the encoder are too big for the M2 screws, at least what seems to, from here. So good thing we have washers with the M2 screws. So we're just inserting this along with the washers.
Okay, this size is way off for the encoders. I think we will have to clarify this in the video as well. So let me zoom in close to the camera and let me try and show this.
I think with the help of washers, it can be corrected like this. You can see that now it's aligning over here.
Let me grab some washers and screws.
These are very tiny, so it's very easy to for them to slip off of your hand.
Yeah, even with the washers it's really difficult to get it right. At least in the case of this. And maybe one more.
Just bring them over here.
Is it like the same case for the 5010 actuator?
Yep.
Oh
Attach.
no. I made a big mistake.
Yeah, just like I said, you have to be very precise with these
But
parts.
it just went in the like motor.
Somewhere within the motor.
Yeah, somewhere within the motor.
Can you see somewhere over here?
Nope.
It won't come out because the motor is magnetic.
Yeah, this part. Yeah, I think we can grab this part over from here. I need like that okay, we can try and do this with the tweezer. Okay, it's out, but the other screw. Yeah, the motor is not rotating. The screw is causing some issue in there.
We'll need to disassemble this.
Give me your mobile. Let me try to find screw using the flashlight. So a slight mishap happened while trying to put in screws for the encoder. I accidentally dropped a really small M2 screw in the motor windings, and I had to disassemble this whole 6U12 module and reassemble it again. I'm almost done with the reassembly, but yeah, it was a long detour. It's already like really late at night time over here. It's pretty much the morning, and I think we're gonna attach the encoders, all the encoders for these actuators, and then we're gonna see where it goes from there. We might call it a day then. Okay, so this perfect encoder is ready once again. It's working pretty much fine, and now this thing is jumping around a lot, and as you can see, the brass inserts for these are not spot on, but you have to do with what you can. So we're only trying to attach M2 screws diagonally, and we're trying to get them to fit over here somehow. Is it the same for M? I almost dropped it once again. I think you're handling it much better. I think you can add it to all of these. If it's the same like this for MC 5010.
No, for that one, it almost always fits in perfectly.
So you need to be really careful with putting it in there diagonally, or maybe yeah, whatever one is the most available, you can try going with that.
This one is a bit tricky.
Yeah, so the hole sizes are totally off in the other one. Yeah, so if you push one nut all the way through, it holds it pretty nicely in place. Maybe we can try doing that for the 6C12.
I've done it. These two are.
Oh, that's cool. That's cool then. Yeah, I think we have run out of washers. We need to maybe open up a new pack. I think I'm gonna grab some snack sometime soon. Yeah, okay, guys.
Guys, we're just attaching these encoders on top of the actuators, and after this most likely we'll just call it a day.
Yep, there's a lot of soldering work to be done after this, and I think we're gonna do it in the next live stream. It's really troublesome dealing with these small washers. Another thing this humanoid can do, it can deal with the small screws, small washers once, if we program it that way. I bet a lot of humans would want that feature. Deal with the troublesome small screws that get lost every now and then, here and there. A lot of humans would be willing to pay for that. So you can have your robot assemble everything, deal with the screws, the small parts, while you could be watching anime, watching Netflix.
I had some interesting thought. So the entrepreneurial people who might be building this robot might be creating sort of digital products with these. So policies for it to do something which other people can simply download and upload on their humanoid robot, and it will just do that. So they're doing sim to real training and perfecting one policy for the robot. So maybe like pouring glass of water,
Yeah.
or walking or running,
Yeah.
which otherwise a person would need to have a GPU and a lot of training to do. They're doing it, and then they're sort of making it into a digital product,
Yeah,
something like that.
yeah,
And
that makes a lot of
that's
sense.
a very
and
interesting space to look into, actually. That's a very interesting space.
I think we would also need some sort of framework to uh, interpolate these policies between different humanoids. Like, let's say humanoids are on different microcontrollers or different languages, different operating systems, or simply different architectures. Who knows what China
No,
has?
but there are a few ones which are open source, and lots of people use that. For example, the Berkeley is one, and then the KSK Labs is the other one. So they're also making this open source humanoid for developers. We can bind the wires like this. It looks a bit cool. Better for the image. Not just
these
okay.
pesky washers, they are so small and so difficult to grab.
By the way, this idea just came to me in my mind, and it seems like a pretty interesting niche to look
This
into.
is pretty much what like Nvidia did with the.
It's a pretty interesting niche to look into, especially if you're needing robot to do something and train policies, and you figure out that other people might need it later on as well when building their robot. So you just market your policy and create it sort of like a digital product.
Let's place the ones that are done over here. Next to there.
It's the last one, right? Yeah, last one. After this, grab the washers and the nidges once again. Not wanna just leave them like this here. We don't want to return to this lab tomorrow and it's all messed up.
Yep.
Little bit of cleaning right now will help
Yeah.
us tomorrow.
The Berserk Gatsu soundtrack is gonna start playing if we return to the lab tomorrow and it's all like messed up. You lose all that willpower and motivation to work. Okay, let's disconnect this. All the encoders are done.
Yep.
Let's zoom in on a single one so we can show it in the video later on what it looks like when it's attached on the motor. And I have already made the video for the magnets. So yeah, here are all the actuators ready. I am gonna gather all the remaining small ones in a separate bucket now. There is a lot of M2 stuff lying around and let's see if I can grab it, put it in there.
Alright guys, so one thing which I'm really happy about today, and honestly it's a good milestone, I'm happy with the progress today, is that M6C12 actuators are complete and the encoders are attached as well. Now we just simply need to make the soldering connections with the motor drivers. That's pretty much the only part which remains. We don't have the CAN USB right now, so we cannot make those connections, but in terms of soldering only this remains. Other than that, we can just start assembling it on the aluminum profile. So like everything is ready to start assembling on the aluminum profile.
The M3X60 nidges we had lying around, it was such a clutch. We were totally not expecting them to be in our lab, but we used them somewhere in our previous project. I don't even remember where exactly we used them, but that was a real time saver.
Just take a screenshot of this one as well. This.
Yeah, I think let's call it a day here. Guys, thank you so much for tuning in. Today in this live stream we have achieved a lot of new milestones. The biggest one, I think the average view duration is for this live stream is it's gonna be like I don't know in future how much average live duration we're gonna get, but this is our third live stream and average watch duration right now is 5 minutes 41 seconds, which is like really crazy for a electronics based live stream. and there was just a lot of assembly and soldering going on. Thank you for tuning in to this live stream. We have finished assembling these 6E12 actuators, 2 of these, and the remaining 5010 actuators, and we also attached all the encoders for the motor, recording the position of the motors to these actuators. Next up, in the next live stream, we're gonna attach all of these to the upper body of the robot. So the next live stream is gonna be really interesting. First up though, we're gonna solder these wires to these motor controllers. We have 9 of these actuators right now, so it won't take that much time for soldering these. Only 9 motor controllers, and we're gonna attach the CAN bus wires, which we have lying around somewhere around here, and then we're gonna put it all together and make the upper body of the robot, which I am so excited for, and it's probably gonna be in the next live stream that will be happening tomorrow. So if you're excited for that, be sure to subscribe to the channel and stay tuned for the next live stream. And I'm also gonna be making a short video series documenting the whole process. So if you want to build this robot sometime in the future, I'm gonna have a playlist specifically explaining how to build this stuff, how to put everything together. Thank you so much for tuning in this live stream, and yeah, we're gonna call it a day over here. Yep, we're gonna go and grab something to eat now, and see you guys in the next live stream tomorrow. Cheers.